Alright guys, so, well, you guys are in luck because it turns out that the other guy in the other room is doing an absolutely awesome presentation and everybody wants to go see him. So absolutely no one is in this room except for my wife. So you guys are lucky SOBs if you're watching this live stream because I didn't think I was going to be able to take questions from online, but I will be able to. So, periodically, I'll check over here on my laptop to see if I have any questions. You guys are welcome to go ahead and chime in on the little live chat there. And if I catch it, then I will definitely go ahead and answer. I'm going to pull it up actually just before I begin here. Wonder how many people we've got on right now. Say hello in the live chat window if you guys are there. Let's see, what do we got? Alright, so I want to start off by obviously introducing myself. I don't know that too many introductions are necessary for all you guys that are out there in YouTube land. So I of course have my YouTube tutorials on programmingadeasy.com, so you guys hopefully all caught me there and you guys know that you can simply catch me at YouTube or programmingadeasy.com. Of course, my Word website is gartnertechnical.com, so that's Gartner Technical Services, where we're kind of the all-in-one, do-everything shop for your IT needs, including app development. Also on Facebook, you can reach me at facebook.com/programmingadeasy. So if you guys want to catch me there, you guys can go ahead and send messages and post things on the wall there, and I do, of course, post all my updates to Facebook there as well. I have my blog, tech-bits.blogspot.com. So if you guys want to check it out there, I also put other stuff that I don't necessarily put on YouTube. I put it up on the blog. Things like little code snippets and things that I come across. I sometimes post up there, as well as it's also a tech blog. So sometimes I'll post some IT-related stuff in Active Directory, Windows, that sort of thing. Obviously, I am the Senior Software Architect for Gartner Technical Services, and I do consulting for both in IT and software development. I've been doing this for a long time in both sectors, so you guys can get me out there. As a matter of fact, sometimes I get asked what's the first coding language that you learned, and I actually learned, some of you may be familiar with IRC, or Internet Relay Chat. The first program I ever programmed in was MIRC, which was a client for the IRC. SQL Server, EA, of course. I got to know my SQL Server in order to do some of this stuff. Full .NET Stack Developer. As you guys have seen on YouTube, I do a lot of .NET stuff. And then, of course, I do have an emphasis because no full .NET Stack Developer actually does everything as a specialty. They focus kind of on one thing. My specialty is ASP.NET MVC and Web API. I work with MVC 3, 4, 5, and now the ASP.NET MVC Core, which is what I'm currently doing. So, let's see, what do we got here? My little clicker going to work? Did my battery die on me? I hope my battery did not die. Oh, I know why I need to do it. Switch over to this. There we go. Hand soap in the 1920s. Who remembers the 1920s? Anybody? No? Okay. Well, back in the 1920s, hand soap became in a powdered form. Okay. And you got this like dispenser that you see here. It was like a metallic top and plastic kind of a metal grade kind of I don't know, like a polymer that would kind of, you put this powder inside of these dispensers, and then the dispensers have like a little lever on the bottom, and you push your hand in there, and a little bit of the soap would fall out. So what you would do is you would get your hands all wet and you get the powder soap. And there's still some of these things that exist. You may have actually come across some of these. They're kind of a pretty old, obviously. But back in the 20s, primarily instead of these type of things. But there was the ivory soap bar that was starting to come out. And the ivory soap bar was really, really cool because obviously you didn't need to have one of these special dispensers. You had to constantly clean out all the time. So the ivory bars were really starting to become a big hit with people. And what they did was, obviously, the powder soaps were starting to lose their market share. So what ends up happening for Control Products Company is that it falls in the lap of a 21-year-old kid named Cleo. So Cleo owns this Control Products Company, and the Control Products Company is losing its market share in soaps and powder soaps. And everything else, all the other products that they previously sold were gone. They couldn't sell them anymore. So really hand soaps were the only thing that they had left. And then poor Cleo at 21 has this company, he doesn't know what to do with it, so he gets his brother, Noah, involved. And he asks his brother, Noah, to come help him out. And Noah says, sure, absolutely, I'll go ahead and do that. And around, it was in 1933, that they had a meeting with Kroger. Now Kroger, they saw an opportunity, they saw a market, but no product, okay? And that opportunity was with coal stoves. Now coal stoves, they were the primary source of heating in the home during the 1920s and 30s, and even a little bit earlier. They were more efficient than wood stoves, okay? They were more efficient because they had a nice little burning coal, and they kept the house very nice and warm without putting out a lot of, they put out a lot of heat without having to be in some sort of chamber that was, containing flames of high velocity or anything like that. They were a really nice solution for heating up the home and cooking your goods. But there was a problem, there was a downside to these coal stoves, and that is that they had this sooty, ashy thing, residue that was left on all the walls and all the ceilings and all that. And so what are they going to do with it? What are they going to do with this? Oh, it looks like... You here for the solid talk?
She's here for the solid, I'm here for the humor.
Okay, solid's in here.
So I'm going to give her her computer.
Oh, okay. Looks like you're the only one. That's my wife there, so.
Oh, awesome.
Yeah, you got me all yourself, yes.
You're going to get awesome stuff.
So I can start all the way back to the beginning. I got all my YouTube followers. Oh, I have an echo. Uh-oh. Ugh. Oh, it's probably because the room echoes. Ooh. Okay. Thank you. Let me see if I can fix that. I don't know how. Maybe I'm too loud. Turn down the. I will turn down the audio here. All right, I hope that's better for people. Thank you. Yes, I would not have known that. Echo is bad. Hello. Yes, please fix the sound. There is echo. Is that any better? I know I'm on about a minute delay here with my YouTube guys, so I gotta start over. I actually got somebody in here, which is awesome because I was really wondering if anybody was gonna show. So, what programming language do you program in?
Well, I've been learning C# for a while, and then out of loop because of personal reasons, but I'm back in now, so I'm kind of re-jogging my brain.
Perfect.
In the fuzziness, yeah.
The code that I'm going to show you is in C#, so it should be right up your alley. Perfect. Okay. So I hope my YouTube crowd is better with the audio. I don't know if it is. I had to turn down the microphone, so hopefully it's not as bad an echo with the. Maybe. I'll turn this down too. Set that down to 75. I turned the gain down to 75, so hopefully that should fix it. All right, all my poor folks out there in YouTube land. All right. Okay, so I can get started again. Only 10 minutes late. So, in case you don't know who I am, my name is Steve Bishop. I'm the Senior Software Architect for Gartner Technical Services. And I have a website called programmingmadeeasy.com where I have a lot of tutorials. I have over 300 videos up there on tutorials on C# and other things, ASP.NET, all that good stuff. I actually work for a company called Gartner Technical Services, and we do have a site, gartnertechnical.com. We do everything for IT. We do software development, we do website building, and we do technical support for things like, you need a new computer, you need someone to manage your network, Active Directory, domain controller, you need someone to hook up your internet, that sort of thing. We do it all. I have a blog, tech.tid-bits.blogspot.com, and I know I still screwed that up. tech-tid-bits.blogspot.com. There we go. And I got everything up there, including software development stuff and technical support stuff goes up there too. Much better? Video, okay. So, I do consulting in both IT and software development. I've been doing it for over 15 years. On the IT side, I've worked for companies that are Fortune 500 companies. I've worked in small little mom and pop shops that have 2 computers and just need to know how to make a website. I've done it all. SQL Server DBA, so I do administration for SQL servers as well. I'm a full .NET stack developer, but typically with .NET, because it's such a wide array of things you can do with it, there's typically some sort of speciality, and my specialty is in ASP.NET MVC and Web API. So that is what I emphasize on, but I can do it all. I've even done some stuff in Xamarin and WPF and all that good stuff. So that's a little bit about me. Hand soap in the 1920s. You remember the 1920s?
No.
No, I don't remember either. So back in the 1920s, there was this, hand soap was actually powdered, okay? And it came in these dispensers like this, and you can actually still find there. I've walked into places where they still have these, especially in like government offices. You'll find that they still have these dispensers like this. But back in the 1920s, the ivory bar was starting to become a thing, okay, which is obviously what we all use now. Well, some of us has the pump stuff, but the ivory soap bars are really, really popular. And they were starting to intrude on the market share of the powdered hand soaps because obviously it's much easier you can buy it right off the shelf. You don't have to have a special dispenser for it. You can just, it's easy for upkeep. I mean, as soon as you're done with it, either it's gone or you just throw it in the trash. And these things were hard to clean out. They got rusty. You'd have to change them out all the time, and they were expensive. It was an expensive solution for hand soap. So this was a fantastic solution. And one of the companies that was selling powdered hand soap was a company called Catal Products Company. And this company was owned by a 21-year-old named Cleo. Now, he had a problem, obviously, because he had only hand soap that he could sell. This powdered hand soap. He wasn't selling the ivory stuff. And all the other products that Catal Products Company had been previously making all fell off. They were all done. So the only thing that they sold was this powdered hand soap. And so this 21-year-old asks his brother to come help him out and try to figure out a solution to making Catal products continue to work. So Cleo and his brother Noah get to work to try to find some way to keep their company afloat. And they get a meeting in 1933 with Kroger. You know Kroger? Okay. So in 1933, they get a meeting with Kroger, and Kroger sees an opportunity for a product that doesn't yet exist. They know that there's an opportunity, there's a market for something, but the product hasn't been created yet. And that problem was coal stoves. So coal stoves back in the 1920s and 30s was the primary way that people heated up their food and heated up their houses, okay? But there was a problem with coal stoves, and that was it left this sooty, ashy residue all over the walls and the ceilings. And you can see on the picture that there's no piping for this, right? There's no ventilation with where all this coal smoke goes. It goes right into the house and it causes this icky, sooty, ashy residue all over everything. It's terrible. So Kroger has this meeting with Cleo and Noah, and they're like, so can you make a cleaner for walls? And Noah at first is like, well, we just make soap. So, and Cleo's like, sure, yeah, we could do it, right? We need to save this company, so yeah, we could do it. Well, it turns out Noah is the smarter of the two. So he goes about trying to come up with the mixture, okay? He's got to come up with some solution for this wall cleaner. And he starts digging around all the items that he's got in the house, and he's taking different things and mixing them together and seeing what works. And he finally happens across this mixture of flour, water, salt, boric acid, and mineral oil, okay? And he takes this mixture and he heats it up. And after about 6 to 8 minutes, it turns into this goopy, like, it's a gloopy, sticky kind of mixture, like a doughy kind of thing. Mm-hmm. And what you can do is you can take this dough and you can smack it up against the wall, rub it all over, and then just peel it right off. Worked great, right? It's a perfect solution. And so sure enough, they go to market and they call this stuff the Catal wall cleaner, non-crumbly type. Great solution. It's off the charts. Everybody's buying this stuff up. They can't keep it on the shelf. So Catal is back in fashion. They've got a great company and everything's going fantastic for them. But there is a lingering little problem on the horizon, and that is oil and gas. They're starting to become the main way that people heat their homes, because now you have oil furnaces. And gas is a much cleaner burning fuel for cooking around the house. And this doesn't leave the coal residue that the coal stoves do. So the coal stoves start to go out of market. And of course, with the coal stoves going out of market, there's no more coal smoke for the product, okay? So Noah, in 1949, he's got some problems. First, sales start to slow down. Okay, obviously, that's what we were just talking about. The second thing is Cleo dies in a tragic airplane accident. So his brother dies. Makes him very sad. Okay, crap. So what is Noah gonna do? Well, Noah, who's still very unhappy, goes and talks to his nephew, Joe. And Joe, well, Noah's like, damn, you're handsome. That's a handsome looking guy there. Probably has like lots of girls that he's taken out at night and needs the money, right? So hey, come work for me, right? So Joe's like, okay, sure, why not? I do need the money. And this, of course, makes Noah happy again, so all right. Okay, so now they've got this new partnership going between Noah, who's the brains of the operation, and Joe, who's basically the face of the operation. And it just so happens that Joe has a sister-in-law named Kay. Now, Kay works at a nursery. So Kay has all these kids that she's wrangling, and she's always got to come up with new ideas of what to do with the kids. And she thinks about it for a while, and she realizes her brother-in-law, he runs this company, Catal, and they've got this product, this wall cleaner stuff that is goopy and messy and stuff, and the kids, every time she uses it around the house, the kids always dig into it and stuff. So she's gonna bring it to the school with her one day, and she lets the kids play around with it, and the kids are just ecstatic. They love this stuff. So Kay goes to Joe and tells him all about how much the kids love this wall cleaner stuff. So what Joe decides to do next is pretty amazing, but that is not the topic of this conversation. This is about solid principles. Practices for making better code. Don't worry, there will be a payoff at the end. I will tell you exactly what happens with Joe.
I gotta guess.
Okay. So, solid principles practices for making better code. SOLID is actually an acronym. It stands for Single Responsibility Principle. And the Single Responsibility Principle states every module or class should have responsibility over a single, just one, part of the functionality provided by the software. Okay? The O stands for Open Closed Principle, and I'll give you a link to the slides so you can copy all this stuff down if you need to later.
Oh, cool.
Okay. Open-close principle, which stands for classes, or which says classes, modules, and functions should be open for extension but closed for modification. And that probably sounds very duplicitous, right? How can something be open for extension but closed for modification? Seems a little kind of duplicitous there, but we'll get to that. Liskov Substitution Principle. This is the one that, when people try to remember the solid principles, this is the one that everybody seems to have trouble remembering how it works. And I think it has a lot to do with the fact that it's the only one with the person's name in it that created it. All the others actually have some sort of description about what it is. But the Liskov Substitution Principle is pretty important, especially if you use base classes. And that is, subclasses should be interchangeable with their base classes. Pretty simple. You should be able to have a base class, and then any subclass that derives from that should be swappable. You should be able to put that subclass in wherever that base class is. Okay? Interface Segregation Principle. Have you used interfaces?
No.
No? Okay. Do you know what an interface is?
I got a short explanation before getting here, but...
Okay, no problem. No problem. We'll go over it a little bit.
Yeah.
You're lucky that you're the only one here because I can actually go over that with you.
Awesome.
So no client should be forced to depend on methods it does not use. So no client, and this means like a class that uses an interface, no client should be forced to depend on methods it does not use. And essentially what that works out to is make smaller interfaces and more of them, okay? And then finally, the D in solid stands for Dependency Inversion Principle. Have you heard of Dependency Injection? No, okay. Good, because Dependency Injection is one people often get confused with the Dependency Inversion Principle. They're not the same thing, but they are related. Okay. And we'll go over Dependency Injection also. So Dependency Inversion Principle basically says high-level modules should not depend on low-level modules. Both should depend on abstractions. Okay? Do you know what abstractions are? We'll get over that too. Trust me, that's why we have this, that's why we're doing this talk. So high-level modules should not depend on low-level modules. High-level modules would be like your user interface, your database. Well, actually, that's more low-level. But all your low-level classes and your high-level classes should not have to rely directly upon each other. They actually both depend on it, abstractions. We'll talk about abstractions. There's abstract classes and interfaces. Have you heard of abstract classes or interface? Well, we talked about interfaces.
Well, yeah.
Abstract classes are very similar to interfaces. They're kind of two of the same thing.
Okay.
So, now, why would we want to do solid? Why is it important to do solid code? Well, that's because the result that we get out of doing solid code, on the good side of doing solid code, is that you get what's called decoupled code. That is, things don't directly rely upon other things. You have kind of an independence. Everything is siloed. So if something needs to be changed, it's very easy to change out. Okay? Which means it's easier to maintain your code. It's easier to extend your code to make other things work with the things you've already got. It's easier to replace the parts of your code, and it's also easier to test.
So everything is independent, but also simultaneously interdependent.
Yes,
Okay.
because they're all relying on abstractions. They only know that there's some sort of abstract thing that they can rely upon. They just don't know the concrete instance of what's going to be coming to them. They only know that there's something there, and we'll see that. I'll definitely, you'll see some examples of that. Now, the bad of this is you have to do more thinking. Okay, you actually have to think about what it is you're doing. You can't just go, well, I'm going to start doing this.
Yeah.
Okay, more code. Maybe. It can take more time. Maybe. And it can cost more money. Maybe. Okay? These three things are very dependent upon a particular factor here. And let's just go over real quick how non-solid code looks when you go through the life of the project, the lifetime of the project. Have you ever heard of Agile?
Yeah.
Okay. So you have iterations that you're doing these things in, right? You're doing one iteration of code, then you have another block of code, then you have another block of code, and you do these, you release your code in these iterative styles, right? So let's say your first iteration, the new code, this light blue kind of aquamarine color is all new code. The top darker blue is legacy code that you have to support, okay? So the amount of time that you have on your first iteration to do new code is 100% because it's your first iteration. You get nothing but new code that you have to create. Iteration 2, you have to start supporting some of that code that you previously did, because anytime you want to make a change with something new, sometimes it's going to affect some of the older stuff, right? So you have to go and kind of modify and fix that older legacy code, right? You with me so far?
Yes.
Okay. And as we get more and more iterations down the road, we find that in order for us to make this 10 or 20% of new code, we end up having to spend a bunch of our time making the old legacy code work with the new changes that we're putting in. Have you experienced that?
With non-solid code, yes. Yes.
Yeah.
I know this is very familiar.
Yeah, very, very familiar, I'm sure. So what ends up happening though, if you have solid code, it starts to look like this. Your first iteration, of course, is going to be mostly new code. Your second iteration, only about 20% of it is actually supporting or changing or fixing old code, because everything you start to do is about new. Mm-hmm. Same thing with iteration 3, and iteration 4, and iteration 5. Because everything is easier to maintain, it's more manageable, it's easy to swap out things. When things break, you just make a new one and put it in place. Which means by definition, you're creating something new to replace the old stuff instead of fixing the old stuff. Mm-hmm. So you actually create new things. Now, imagine for a moment that you are the client and you're receiving new stuff every time. You're getting everything you want implemented for each iteration is getting implemented. What kind of value does that have to the client?
Infinite.
Yeah, it's great, right? So all this great stuff, right? All this good, wonderful things that we can do for our clients by doing solid code. But obviously we have to understand how to do solid code. So one analogy I like to talk about with solid code, because the bottom line is when you do solid code, you make lots and lots of little things. In a typical non-solid code system, you can imagine that you're using big giant building blocks like this. So each one of these blocks represents a piece of your code, right? And they all form and fit together. Can you figure out what this thing is that's been created by these big blocks?
T-Rex.
You think that's a T-Rex?
Yeah.
Okay, what about, so we know that's a dinosaur. This is a dinosaur.
Yeah.
What about this thing?
Chicken.
A chicken? Yeah, maybe. I mean, we don't really know. We have no idea what that is, right? It could be a man, could be a chicken, could be, I don't know what it is. I don't really know. Okay, but if we use small blocks, not only can we tell that's a T-Rex, but I mean, look at the detail on this. Look at the detail on the tail. Look at the detail on the feet. You can tell it has bird-like feet. I mean, here, if we look at the big blocks, there's no bird-like feet there, right? We can't really tell the shape or the design of it. The tail is much better. I mean, the stability of this thing is better, right? We've got a tail that kind of equals out the weight of this thing so it can stand on 2 feet like that. It's not even relying on the tail anymore. You've even got teeth, which is really cool. You got claws. You got so much more detail because you're using smaller building blocks to build this thing. Okay, so that's clearly a dinosaur. We know that that's a Tyrannosaurus Rex, and that's a man. We tell that's a man because we can see the detail on it, right?
Not a chicken.
Not a chicken. So let's go over each one of these solid principles one at a time. Single responsibility principle. What happens is when you use single responsibility principle in the way that it should be used, it actually creates the architecture of your application for you. Okay, so you don't have to think about architecture ahead of time. It just comes out of doing the single responsibility principle. And again, just to reiterate, the single responsibility principle states that every module or class should have responsibility over a single part of the functionality. Okay?
Yes.
So one thing. That class or module should have responsibility of one thing, and that's it. Now, I find it ironic, I find it really funny that if you go and make an ASP.NET MVC core application out of the box, right out of the box, the first template that gets built by Microsoft when you go to create a new MVC application, the first thing that they give you is this thing called a home controller. You know what a controller is in MVC? Have you done MVC before?
No, I haven't done MVC before.
Okay. MVC is a way of making your code, it is decoupled code because you have models, you have views, and you have controllers. Your models are your data, your data objects. Okay, they define what is a person, what is a customer, what is a client, what is a phone number, what is an address. So you have these little things, classes that just specifically are like the properties that entail what each one of those things are, and we call those entities or models. Okay. So that's the M part. The V part is obviously the view. You create a view. MVC is a web architecture. So you create a view for your customers or your clients that come view the page. Your view is a separate entity that's just going to have the HTML markup language and also Razor markup language, which is how we integrate code into a view. So if you want to pull data from a model and put it into the view, you use Razor code. So that's basically what the view is. And then a controller is basically what choreographs this dance between the data over here, putting it into the view, and then returning it back to the user so they can view it on their browser.
So it's the thing that holds everything together.
Right. It's the choreographer, right?
Yeah.
When somebody calls the controller, okay, they call basically one of these actions: index, about, contact, or error. Okay, on the home controller, and the MVC architecture knows, based upon the URL that the user typed in or clicked on a link to get there, to call one of these different methods on that controller. Okay. Now what's interesting is if you look at this home controller, this is what comes right out of the box. This is a class with 4 different methods on it. What does the contact action, what does the contact page have to do with the home page?
It's connected.
How?
Through link.
Through links. But are they related in any way?
No.
No. There's just a link.
Yeah.
But there should be other controllers that the home page might link to too. Why are these 4 things grouped together in this home controller? What does an error page have to do with the home controller? Or the home page? What does the about page have to do with the home page? They're really all separate things.
Yeah.
But right out of the box, Microsoft is already putting us in this situation where we've got 4 different responsibilities that this one controller is in charge of. So they've already started us out down the path that's wrong. Right out of the box. That's the template you get and how they tell you how to do it. So what we really should do with this is we should isolate the home controller to just doing the index action.
Okay.
Okay? And then we take these other 3 actions and we create their own controllers. So that this about controller class has 1 action on it. This contact controller class has 1 action. Error controller has 1 action. So now we've isolated, we've split up each one of these controllers to handle 1 responsibility, 1 page that controller is in charge of pulling up. Does that make sense?
Yes.
Now, what I like to do is I like to create another class underneath this I call it the orchestrator class. I've seen it called the interactor. It's just basically where all my logic goes. So rather than have my about controller have all of the code behind the about action do anything, I actually make that logic in a whole other class altogether. And I just make that action, that about action, call the method on that operator. Okay? Same thing with my contact controller. It calls this method called getContactPage. And then my error controller actually the orchestrator has 2 different things that it does, because really, if I have an error in my application, I don't just want to show an error page, I also want to log the error. I want to keep track of where my errors are, right? So this orchestrator's got 2 different things that it does, sort of. Okay, we'll get to that a little bit later, but the error controller is asking the orchestrator to do whatever logic it is that I want it to do, rather than having the logic behind the controller itself. Okay?
And this is where interfaces come in?
We'll get to interfaces a
Okay.
little bit, yeah. So, then we have to have obviously the view that we bring back to the customer or back to the user. We have to have something to show them when we're done, some sort of output, right? So our views, what the get about page view, about page action is going to do is it's going to return that about view. Same thing with this orchestrator, the contact view is going to be returned when the get contact page gets called. Same thing with the get error page. After it does the get error page and it logs the error, then it's going to return the error view. Okay? So we have our views. Now we have our models or entities with the different types of data. For my about page, for example, I might have a description stored in a database somewhere, right? Same thing with the email, phone number, and address. Those might change over time, so I keep them stored in a database, right? I don't want to hard code them in the code. I want to put them in some sort of storage facility somewhere that I can change it. Same with my error info, right? Whenever I'm logging my errors, I might want to save it to a text file or a database or something, okay? So those are my models, but the orchestrator is not going to talk directly to the data, right? Instead, we're going to have another thing in here. I call it a repository or a service, okay? So a repository is a special kind of pattern that allows you to easily swap out your sources. So if I have a description, let's say I have a database that's in Microsoft SQL Server, but we're going to switch over to a PostgreSQL server, a different kind of database backend. Well, rather than have to have this orchestrator know everything about how to connect to that database, I have a repository instead that gives me how to connect to that database. And now I can swap easily. Every time this orchestrator needs to change databases, I just change the repository that it asks for, right? It makes it simple to just swap these out. Same thing for each one of these. Each one of these orchestrators has a repository, or perhaps it's a service, right? Maybe we're getting our service online from some sort of web API or WSC service or something like that, okay? But they also, notice that all these arrows, where are they pointing?
All to the methods there.
To my orchestrator,
Yeah.
okay? These are my dependencies, okay? My dependencies, what these classes rely upon are the yellow arrows. And it may look a little odd at first to see, well, the repository doesn't depend on the orchestrator, but the orchestrator doesn't depend on the repository. It doesn't care which repository it is. All it cares about is that there's some sort of repository that it's going to have. These are the directions we want the inheritance to go, or not the inheritance, but the dependencies to go. We don't want it to go the other way, okay? The question is, how do we do this, right? Which we'll get into.
Okay.
This is your domain layer. This is where all your business rules are. And really, these orchestrators are really just kind of like the top level entry into your business rules. They orchestrate the business rules. They orchestrate how the logic is supposed to go. And how do I get from this information? How do I take all this information from over here? Okay, now which view am I going to get and return back? So it's doing all of this stuff, and it doesn't have to do all the logic directly inside of it. Sometimes you want to break out that logic into their own classes and have the orchestrator call those classes functions instead. So sometimes we want to break it up like that. But this is really the entry to our domain layer or our application layer. Have you heard that term before? Domain layer, application layer?
I've heard it, yeah.
Okay. So this is just because we've split up the responsibilities, right? Mm-hmm. So by obeying the single responsibility principle, we've broken up each responsibility into their respective classes, okay? And what we end up with is our domain layer here. Here's our data access layer. You've probably heard that term before. Here's our service layer. You may have heard of that term before, or repository layer. Our user interface layer. And our API. That's our API layer.
Oh.
So just by following along with breaking up everything into these different responsibilities, we create these layers. We don't even have to think about this ahead of time. We don't even have to think about the architecture of our application as long as we obey, break everything up. Okay? So that's pretty awesome, I think. I think that's a great way. Now the API, some people might be confused about this. I'm not confusing this with a web API. An API is basically the point, the end point of your application. Where does somebody get entry into and get data out of? Right? That is what an API is. I need to call that function. That is my endpoint that I call, and I receive this data back. That is exactly what an API is. So these controllers are your API. They define what the endpoints of your application are that somebody can call and what kind of data is going to be returned. Okay, so we have separated out the call layer, the API layer, separate from the UI layer, and here's our data access layer and our service layer, but the domain layers where all the business rules are going to figure everything out, and they're all just kind of, they're all separate, right? We've got a real nice architecture here as a result. So the open-close principle. Classes, modules, and functions should be open for extension, but closed for modification. Let's start out with this little function here. Public void do something, where we instantiate an instance of new business rule and assign it to this variable called business rule. And then we execute. We call the execute method on that business rule, right? You've probably seen code like this.
Yes.
Right? Very simple. But there's a problem. This is very coupled code. There's a direct reliance. This do something method has a direct reliance on that business rule. If I make a change to business rule, what happens to my do something method?
It completely changes what that method
Exactly.
completes.
And now I have to go find everywhere in my code where this business rule is being created, and I have to go fix that other method to use that the new instance of my class. Right?
Yes.
So there's a problem. This is coupled code. I am coupling my methods with these classes because I've instantiated it right here inside of my method.
I'm so guilty of that.
Uh-huh.
Thank you.
Okay. This is better. Public void do something, I business rule as a parameter. Now, call execute method on that business rule. If I took the I out of this, this would probably make immediate sense to you, right? Instead of having do something, call, instantiate new business rule, it just gets passed in an instance of business rule and then executes it, right? That would make sense, right?
Mm-hmm.
But there would, if I did that, there would still be a dependency upon business rule doing exactly what it's supposed to. This I in front of business rule indicates that what you're actually passing in is an interface, okay? Now an interface is, I will talk more about interfaces, but they are essentially a contract. You know how you can base a class on another class, right? You have inheritance. You can create these things called interfaces, which are defining the members of a class. If I created an iBusiness rule interface, I would say on it, I am defining on it, this interface that there will be an execute method on it, okay? You know what a method signature is?
No.
Okay. This here is the method signature. Public void do something.
Okay.
Takes no parameters.
Mm-hmm.
That is the method signature, okay? It's a public, has a public access modifier. It returns void. That's the name of it. And then if I had any parameters, it would be inside of there too.
Yeah.
This is also a signature. These two are different, right?
Mm-hmm.
So we could do something called method overloading, right? We could have these two methods could both be on the same class,
Yeah.
right? Because the signatures are different,
Yes.
okay? When you define an interface, you only define the signatures. You don't define the logic behind them,
Okay.
okay? So I only say a business rule has an execute method, and it's publicly available, and it returns void. So essentially, if I wanted to make an I do something interface, I would say on it, okay, the I do something class has this method called do something that is public and returns void. So you just define on an interface what the methods are. That if this class was going to inherit from I business rule, it must have that execute method on it. Does that make sense? Are you sure?
Yeah, something somewhere has to say how it works.
Yes. And I'm creating what's called a contract. I am saying, I don't know how this business rule, I don't know what it's going to do when you call the execute method. All I'm guaranteeing you is that there is an execute method. And now I could create business rule that implements iBusiness rule, or I could create new business rule that implements iBusiness rule. I could create second business rule that implements iBusiness rule. And I can guarantee that each one of those classes, because they implement iBusiness rule, all of them have a definition for the execute method. Therefore, this do something method doesn't care which of those classes I pass into it, just so long as they implement the iBusiness rule. Does that make sense? Because we know that the iBusiness rule must have an execute method on it, so it doesn't care which one of those classes, which concrete class you implement and pass into it, just so long as this do something method knows it can call execute. That's it. That's all that matters. Now this is what we call decoupled code. Because now the do something method doesn't care what instance of business rule you run, just as long as that business rule class implements iBusiness rule. That's all that it cares about, okay? iBusiness rule interfaces are an abstraction because they just define those methods. They just define the signatures. They don't define the logic, okay? Now, I'm going to kick it up a notch. Public void do something list of iBusiness rule. So this time, I'm not passing in a single business rule. I'm going to pass in a list of business rules. And then for each one of them, I'm going to call the execute method.
Okay.
If I passed in just one business rule to this in a list, would it work?
Yeah.
What if I passed in 1,000,000 business rules into it? Would it work?
If it didn't crash.
Okay, if it didn't crash, right? It'd probably hang and somebody would go, click, come on, do something. But the bottom line is it works, right?
Yeah.
This won't fail. It's been extended, okay? We can add as many business rules as we want. We can send as many business rules to this as we want, as many or as few, and it will still work. This is ultimate cosmic power, right? We have extended the bejesus out of this little something that was just calling and executing this. Now we can actually call execute on anything. Any business rule that we want to pass into it, we can execute it, okay?
Yeah.
So we've supercharged this just by having 2 extra lines of code. All right, so that's the open close principle. Thinking about how you can make your methods do more without having to do a whole bunch more coding to make it happen, right? Just adding a for each loop and making a list. Is that a lot to do? No. But by thinking about these things ahead of time, of how can I make this more extensible? How can I make this method more extensible? You create the opportunity to do better things with it.
How can I make ultimate cosmic power?
Yeah, exactly. Okay, next one. Liskov Substitution Principle. Subclasses should be interchangeable with their base class.
All right, this is going to be entirely new from my perspective, so.
Okay. Liskov Substitution Principle. If it looks like a duck, quacks like a duck, but needs batteries, you probably have the wrong abstraction. You shouldn't need batteries. Okay, so let's start off with this bird class. Bird class that eats, poops, and flies. Okay. Now the bird class works perfectly fine to inherit from for the pigeon class, because the pigeon eats, poops, and flies. That's perfectly fine. But what happens when we try to inherit bird class for penguin class?
You've got a penguin that can fly.
You got apparently a penguin that can fly, and that's not good. Because penguins don't fly. We shouldn't have to try to implement fly, and if there was some logic here behind the fly, which there should be, right, between just a regular class, there's some sort of logic behind fly that does something. And the penguin class is going to inherit from it? Apparently, right. Like, penguins suddenly can fly. That's not right. So that won't work. We cannot inherit from bird class for penguin class. What we should have done was made bird class just eat and poop. Okay, now the penguin class can actually inherit from bird class, and that works perfectly fine. And now we change the original bird class to flying bird class, and we add the fly method to it. So now the flying bird class can inherit from bird class. That works fine, right? Because flying bird class can be replaced wherever we have bird class. This is fine. We can put a flying bird class in anywhere that there is bird class, right? Mm-hmm. And now our pigeon class, if we inherit from flying bird class, now not only can pigeon bird class inherit from or go wherever flying bird class is. So if we have flying bird class somewhere in our code that's being called upon, we can replace it with pigeon class and it'll work just fine, right? Because these methods still all exist. These are the same methods. And even if there was a bird class out there, we could still put a pigeon class in there and it would work just fine, right? Because even though wherever this bird class exists, wherever that code is, it's never going to call this fly function.
Yeah.
But it will be calling the eat and the poop, and it doesn't really matter. It still works. The pigeon class can be replaced wherever bird class is. The pigeon class can be replaced wherever flying bird class is. And penguin class can go wherever bird class is, but it can't do this way.
Yeah.
Okay? That is the Liskov Substitution Principle. Okay? You should be able to, all your subclasses should be interchangeable with their base class. So I have a base class here. This subclass of the base class could go in wherever this is. And then same here. This pigeon class could go in anywhere this class is or this class is, which this inherits down the line from, right? So it can go in any one of those other two places. That is the Liskov Substitution Principle. Now we have the Interface Segregation Principle. No client should be forced to depend on methods it does not use. This is very similar to the Liskov Substitution Principle. The two often get conflated with one another, but there is a slight little distinction here. So let's start off again with our pigeon class and our penguin class. Okay, the pigeon class, we know we want it to eat, poop, and fly. Penguin class just eats and poops. All right. We're going to create iBird, an interface that just defines that any class that inherits from iBird must implement eat and poop. Okay, and again, an interface doesn't have any actual logic behind it. It just defines the members. There is an eat method on here, there is a poop method on here. So penguin class can inherit from this iBird interface, no problem. No problem at all. We could make pigeon class also inherit from iBird. We could, but there's actually something better we can do because we've got this fly method here, which is not defined by the interface. Okay, so this would work, but there's something better. Instead, let's create another interface that defines that, I'm going to call it an iFly interface, that says that any class that inherits from iFly must have a fly method on it. Okay? Now, what we can do is we can actually add a third interface, because interfaces can inherit from multiple classes, right? That was something we couldn't do back here with the Liskov Substitution Principle, right? You can only inherit from one base class,
Okay.
right? Interfaces work differently, and that's why we like them so much, is because I can create an interface called iFlyingBird that inherits from both iBird and iFly.
Okay.
Now I can say my pigeon class inherits from iFlyingBird, and in fact, I didn't even really need this. I could have said my pigeon class inherits both from iFly and iBird. That would have worked just fine too. But I like doing this. I like to be able to do this wherever possible. Create some sort of combination. This interface, I guarantee, combines both of those two things. And now I can create a pigeon class, I can create a sparrow class, I can create a dove class, I can create whatever kind of classes, and just keep inheriting from that iFlyingBird. And I'm guaranteeing that those classes that inherit from iFlyingBird will have the iFly method, the eat, and the poop method. Okay, so now my pigeon class inherits from iFlyingBird, has all three of those, and here's the kicker. Anywhere any three of these classes are so back when I did my my interface and that do something method, I was saying it needed some business rule. I could pass in an bird, I could pass in an fly, or I could pass in an flying bird, and the pigeon class could be the concrete instance that would implement in any of those cases. So if my do something method just needed to make sure that you call the fly method on it, I could pass in a pigeon class.
Okay.
Right? But the penguin class, since it's inheriting from bird, it doesn't inherit from fly, you can't pass in the penguin class. That make sense?
Okay.
Question? You look quizzical.
I think it might be easier to, I get it very conceptually, it might be easier to see it sort of.
In code.
Yeah,
I got code for you a little bit later.
thank you.
Yeah, no problem. I just kind of want to cover these conceptually first, and then we'll go into some code.
Yeah.
Okay, so that's the interface segregation principle. Now this is the thing that makes it separate from the Liskov substitution principle. We're saying that flying bird, we cannot force the penguin class to inherit from flying bird because of the fly method. We cannot force the penguin class to inherit from fly or flying bird because that would force it to implement fly. But the penguin class doesn't have any way to fly. So what we would end up probably doing is throwing like some not implemented exception. Like this method exists, but I haven't done anything with it, or just returns void. That's kind of lazy. You don't really want to do that.
Yeah.
Okay, or returns the default of something. You don't want to do that. You don't want to just return the default of what it expects if it shouldn't even implement it. Okay. Now finally, Dependency Inversion Principle. High-level modules should not depend on low-level modules. Both should depend on abstractions. So interfaces primarily, but you could also do something called abstract classes. So we have that orchestrator class. And what we're saying here is that anything that goes into it and anything that comes out of it should be an abstraction, not a concrete instance. Okay? It receives information through interfaces, does something on those things, and then it sends back out through interfaces. The only exception to that would be if you're using a primitive, like a string or an int or a double. If your function is returning a basic string, int, double, decimal, something like that, and a non-complex object back, then that's perfectly fine. But if you are going to have a class that orchestrator is supposed to return back, it should be sending back an abstraction, saying that what I'm going to send you back is an interface. Okay? Mm-hmm. Now what we do is we have this business rule over here that also has abstractions that its inputs and outputs are. So we don't have any concrete classes here that are defined in any of them. That's because we're saying, remember in the open-close principle, no new objects. We don't want to be instantiating a new object in either of these two things, right? We don't want our orchestrators to be instantiating a new instance of anything because now we're coupling our code. Same thing with the business rule. We don't want to instantiate a new thing, even if that is what's supposed to go out, right? Even if that object that's supposed to go back out of the business rule, if it's a complex object, we don't want to new up that complex object. We want to say, no, it's an abstraction that we're sending back to you. That way, both of these two things don't depend directly upon each other like that. There's no coupled code here. So what we have is like two interfaces. One, let's say iRepository and iResponse. So your iRepository is your connection to your database, right? It's how your CRUD actions are being exposed. Create, read, update, delete, right? You've heard the CRUD acronym before, I imagine. So your iRepository exposes the create, read, update, delete of whatever that object is that you're going to create, update, or delete. iResponse, this is interesting. This is probably something you're never going to hear. I don't know, I'm not going to say I'm the one that created this idea. I don't think I am. It just came like out of thinking about this and doing this enough times. The response object that the orchestrator should expect back from the business rule should be an iResponse object, some sort of abstraction, right? So the orchestrator expects it's going to send it a repository but it's also going to send it an iResponse, some sort of class that implements iResponse and send it to the business rule. So this is already defining what it expects back before the business rule even gets it. There's also something out there you may have heard of called an IOC container. Have you heard of that term before? Inversion of control container. I also call it a dependency resolver. IOC container has many different names, but essentially what it is this iRepository, you can define in a IOC container that if there is an instance of iRepository needed somewhere, then the DB repository is the class that should be sent to it instead, if that makes sense. So this is kind of like watching. It's monitoring to see what are the classes that these things need. Send over this concrete instance, okay? So when this orchestrator sends over, I forgot I had that little thing there, sends over the iRepository and the iResponse, what's actually happening is the dependency resolver picks up on this transaction and actually sends a business rule in a DB repository in place. So as far as the orchestrator is concerned, it doesn't know that this is happening. It's just handing off an iRepository and an iResponse. These are two abstract concepts. An iRepository and an iResponse. It doesn't know what that entails. All it knows is that it has one, it's going to pass it along to the business rule. Now the business rule is going to do whatever it's going to do and then hand back the iResponse back to the orchestrator. Okay? But in the background, this dependency resolver is actually, okay, you need an iResponse? Well, I'm going to create a business rule response. Okay?
Okay.
Again, you'll see this in code, I promise.
So,
and go ahead.
The dependency resolver is sort of like a middleman that is always there in case either the business rule or the orchestrator has a change to it, so that they don't have to directly depend on each other.
Right, yeah, because all the orchestrator and the business rule care about is that I have one of these interfaces. Okay, I'm being sent a class that implements iRepository. I'm being sent a class of that implements iResponse. And here's some code here that this whole construct sounds a little complicated being explained, but when you see it like this in code, it probably makes a lot more sense. I have my business rule method. It takes iRepository. It takes it as a parameter, takes an iRepository interface. So some class, like DB repository, can be passed into it and it'll be assigned to the repo object, right? The repo parameter. It also should take the response. So this orchestrator is going to expect some sort of response, but the orchestrator is actually passing in the response that it expects. Now all that's going to happen is the business rule itself is going to take and call the getAll method on the repository, because that's what we've defined on DB repository or any iRepository class. Any class that inherits from iRepository has this getAll method on it. Okay? The business rule doesn't care what it does. All it knows is that it can call that getAll method. And that getAll method will return a response that we're going to assign to this variable called model. And now we're going to assign model to the response.model. Okay, so here's our repository and our response. All we're doing is we're taking the getAll, we're taking whatever comes from that and assigning it to the model property on that response that was handed to it. And then we're just returning the response back out because there's our iResponse. So the inputs, iRepository and iResponse, are abstracts. What it sends back is an abstract.
Yeah, okay.
Make sense?
Yeah.
This is where the actual good stuff happens. But as far as the business rules cares, it doesn't need to know what the concrete instance is. It just needs to know that it can call getAll and that there's a model property on it.
Mm-hmm.
That's all it cares about. It's up to the orchestrator to figure out what are these two things that it should be sending it. Does that make sense?
Yes.
Okay. This part here is called dependency injection. Everything that this business rule method requires to do its job is being injected So all the dependencies of this business rule are being injected into the parameters of the method. Now typically, this actually happens in the constructor of a class. For illustrative purposes, I've done it in the method, but typically these, like the I repository, would actually go into the constructor of the class, okay? I assume you know what constructors are.
No, I'm sort of just,
Okay.
yeah.
So, that is what the difference is between the two. So let's do some workshop stuff. Build an application that takes a vehicle make and vehicle year from the user, and based on a set of business rules, accepts or rejects the entry. Okay, this is what we're going to work on. Build an application that takes a vehicle make and a vehicle year from the user, and based on a set of business rules, accepts or rejects the entry. The rules are as follows. The user can enter either a 2 or a 4-digit year. The make does not need to be case sensitive. We are only accepting Mazdas 1997 and newer, and we are only accepting Toyotas between 2006 and 1999. Okay, so those are the only business rules that we have. I have a GitHub repo of the solution for you. Okay, so if you go to github.com/xipoo /solid principles demo, I have 2 versions of the answer here. One is a non-solid solution where everything is in one class. The second version, everything is broken down into solid, okay, into all the different components and parts that it's going to need. Joe McVicker made Play-Doh.
I knew it.
So there you go, Joe McVicker. He did not necessarily invent Play-Doh. His uncle did, Noah, but Joe McVicker capitalized on it, decided to remarket the wall cleaner as Play-Doh and put coloring to it. And now that's what we know it as, is Play-Doh. So, yeah. So I decided to put the solid principles back up there for you guys. Any questions? Any questions?
So far, no.
No, nothing yet?
So far, I'm just internalizing.
Okay, doesn't look like I have any online questions either. Okay. So, I assume you want to see some code. Let's do that. Let's do that. And this is going to mess with me if I try to do it that way, so I'm going to try to... there. Let me see if I can. Bear with me, guys. I'm going to try to get both screens here to show, because I can't look at that screen behind me and do the code. I'm just not that gifted. Extend, duplicate. Okay. There we go. Can you see that?
Mm-hmm.
I can't tell if it's showing up properly on the screen. Those guys. Okay, anyway, so, all right. So this is the original solution. Let me just make sure that it's the one that starts up here. So if the user goes and enters in, I'm just going to run this. User enters in, make of the car, we'll do Isuzu, which I don't think I spelled that right, but Isuzu, I don't think you can see it. But the year will do 99, and it's going to tell me that the make you entered is not, maybe I can make it bigger. Properties. Position font. Let's make it nice and big. There. A little better? You see that?
Yeah.
Okay. So Isuzu, please enter the year car. The car make you entered is not currently accepted. Would you like to enter another car? And this is just basically looping through. So put something in there. I put in 3 digits and it says year of the car entered must be 2 or 4 digits. Okay. And no, I do not want to try another car. Okay. So this code is pretty straightforward and it's non-solid. We've got, pull this chair around here. All right, so we're pretty simple, just got right line console right line takes the 2 inputs that are entered, the car make and the car year. Mm-hmm. Can you see that?
Yes.
Okay, good. Then it tries to check and make sure that it can convert that value that's been put in for the year into a number. And then if it can't, obviously it says the year entered is not a number. Then it checks to see the length of the car year, checks to make sure if it's not 2 or 4. If it's not, then do 2 or 4 digits. And you'll also notice this is inside of a while loop. So while this is true, just keep going through. So all this stuff happens inside of a loop so that at the very end, I can say, would you like to try another car? And then I set the exit app value to false, or I guess it's true actually, right? So while not exit app. So as long as they keep saying yes, it'll keep going through the loop over and over again until they say no. But there's all this console write line, console read line, checking the length, comparing, there's Toyota there. Checking if the year length is 2, then I need to check and see if it's greater than or equal to 6, or if it's less than or equal to 18. You can probably figure out why I did that. Because if somebody puts in 20, that's not really new, because it might be 1920, right? So your car is too new, your car is too old. That might be a bit of a mistake. Congratulations, your car has been accepted. So if it passes all that, it's good. So this is pretty typical what you would expect to see for something like this, right? This took me like an hour to do, right?
Yeah, this is how I've been generally building my code because I'm so new at this.
Yep. Okay, so let me show you. And I've done a lot of different things with this. I've done a lot of different coding techniques with this. Notice how right from the get-go, look at the distinction between the foldering of my application. Can you see that?
Yeah.
It's kind of small. I wish there was some way to make it bigger, but I don't think there is. I can only make the code bigger. I can't make this window bigger, which really kind of irritates me. Maybe properties, options. I don't know. I haven't had to try to make it bigger, so I don't really know. Anyway, so the foldering on this, and you can also go, guys, if you're on YouTube, you can go to GitHub, the GitHub repository. Again, that's github.com/xipoo/solid principles demo. Here, I'll put that back up on the, it's this right here, GitHub github.com/xip000/solid principles demo. I'll probably put it in the description of the video too, so that when I post this up later on, it'll have the link. But the application is split up into different sections now. Here's that program.
Where's the beer? We heard there's beer.
So the program file, if you compare what we had here,
Yeah.
think about how many responsibilities this main action, this main method had. There's a lot that it's responsible for, right?
Yes.
Here, that's its responsibility. There is this class out there I've called services, which has a service provider property on it. It's in my startup folder. Here's my services class. It's just a static class. And this is what we call an IOC. It's an inversion of control container. Okay? And essentially what's happening here is that I've taken, this is an ASP.NET Core application, and what's great about .NET Core is that they have implemented services or an inversion of control container built right into Core. Okay, so you don't have to get some external utility, it's built right into Core. And essentially you can see how I am saying so my service provider property has a new service collection. This is one of the very few times it's okay to violate this, because this is just basically setting up, this is bootstrapping my application. Okay, and this is one of, I think there's only one other spot in my entire application where I've newed up anything. Okay, this is the only other place. This is the one place that I have it. I'm creating a service collection. It's a collection of services that my application will provide. And you'll notice iApplication, that's an interface. And an interface, if we go to the definition, just declares that an iApplication interface has one method on it called run, and it returns nothing.
Yeah.
Okay? So my program, there's the iApplication interface, and it's assigning whatever the service provider returns back when it gets the service for the iApplication interface. It's going to assign that to app, and then it's going to call the run method on app. Okay, so we're using this iApplication interface, which just defines a run method, and I'm saying, in order to run my application, all you got to do is call run. Now, what happens from there? Well, this iApplication that is being that is declared in the services here, so we're registering that any time that iApplication is needed, new up an instance of solid application. So that is actually where my solid application is. And also look at how the foldering is. My application is under a folder called application. Makes it easy to figure out where it is. There's my solid application class. Notice how it implements iApplication. And there's the run method that's on it.
Oh, okay.
So I'm defining this interface. Any class that implements iApplication must have this run method. Okay, I implement iApplication, there's the run method. Does that make sense?
Yes.
Okay. Now, as part of the constructor here of my solid application, I am saying in order for me to run, I have these two dependencies, iSolid Application Orchestrator and iVehicle. I need these two things in order to work. They're both abstractions. They are not concrete classes. I just need two objects that implement iSolid Application Orchestrator and iVehicle. And if we go back to our services, iSolid Application Orchestrator, iVehicle. So they're registered in this system, right? And each one of these, when they get called, when they get called upon, so if I need an instance of iSolid Application Orchestrator, look at the class that gets called, that actually gets instantiated, right? So this is what's required in order to run. This is the concrete implementation of it. So here's my solid application orchestrator. There's a lot going on here. I can dig into a little bit later, but you're starting to see that we have everything kind of layered and everything is abstracted away. So my application, my solid application that implements iApplication, it's going to take those two interfaces. When it calls the run method, it's got that same while loop that we saw in the original, right?
Yeah.
We saw the same while loop. This time, the vehicle make and the vehicle year are being assigned to, notice that we had this iVehicle object being, it's interface.
Yeah.
It's being passed into the constructor, and then it's being assigned to this private variable called _vehicle. Now down here, we're assigning to that vehicle make, because iVehicle, if we look at the interface, defines two strings, a vehicle make and a vehicle year. So any class that implements iVehicle must have these two strings on it, right?
Yes.
So now when we go and, where is it? So now we know, okay, this vehicle that's being passed in to the constructor and now being assigned to this private variable, I know that it has these two properties on it. And now I can assign the value that comes from this get vehicle make and this get vehicle year. I can assign the values that get returned back from them. I don't know what they do yet, but I can guarantee that number one, that get vehicle make exists and that get vehicle year method exists. I know they exist. How do I know they exist?
Because if you find the definition, it shows that it must exist.
Exactly. That's right here in the iSolid application orchestrator,
Yeah.
which is being passed in again in the constructor as a parameter called orchestrator. And then orchestrator is being assigned to this _orchestrator private variable. And if we looked at iSolid application orchestrator, there's our definition. We know that there will be a get vehicle make and a get vehicle method on whatever class it's going to implement iSolid application orchestrator. It's going to have those two methods on it, and they're going to return a string. We can see they return a string. They absolutely if they're defined here, they must return some sort of string, right? Now, if we look at my solid application orchestrator class, there are my two methods. And look what they do. They just call another orchestrator.
Yeah.
They call methods on another orchestrator. Why would I want to do that?
To prevent the dependency.
Right. Not just the dependency, but what happens if, so this car details orchestrator. Okay, I get car details orchestrator. If we go look at its implementation, I'm going to go back to services. I get car details orchestrator has a get car detail orchestrator. Okay, so we'll go to its definition, and we can see that it returns just these two things. There's my actual prompts.
Yeah.
Okay, but it's essentially a service that I'm providing.
Yeah.
Because what if right now I'm getting it through the console. What if I want to get it through a web page? What if I want it to be an API, a RESTful API, or a WSC application? What if I want it to be a text file that I get somewhere? I could get it any number of different ways. I could get this information from the user, from maybe another database. Doesn't really matter as far as my application is concerned, right?
Yeah.
My application, if we go back to the orchestrator here, all it cares about is that it can call that get vehicle make from whatever that service is that's giving it, right? Whatever this service is that's giving me this get vehicle make method, all I know is it returns some sort of string. And then I'm actually just handing that back up the chain.
Yeah, to whoever wants it.
Exactly. We have validate vehicle, pass in a vehicle. This would just, I think this is probably a little bit beyond where you're probably at with lambda expressions and such, but
So are you seeing how we're getting away from having anything concrete except for what we see here in the services, right? This is the only place in the entire application where I'm saying, if this need is needed, new up a concrete example of this, and new up a new instance of this concrete class. This is the only place in my entire application that happens. I don't have to new up anything. If you look through all the code, if you look through all of the actual concrete classes, there's no new statements. There's no new instances of anything.
Yeah.
There's a solid application orchestrator. There's no new instances of anything. Let's go to the features. Common, there's my vehicle, it's just a data transfer object. Get car details, there's my get car details. Any new objects in there?
No.
No. How about user prompt? This is a service. I've actually created my prompt, the console, I've actually turned into a service. I can do get user input, get user key, or post message. I've just basically repurposed a console to be a service. And now I can output information to whatever I want. In this case, it's a console app. What if I want it to be a web page? What if I want it to be a API, a RESTful API, or something like that?
Yeah.
But again, there's no newing. And also something else you might notice, how much of the page does my code take up?
Like hardly any, like not even half page.
Right? How about here?
Same.
Right? Same. My validation will probably mess you up though. There's my validation result object. That's what each validation result expects back. Here's the validation rule service. That's my service class. That's actually the service. Pass in generics. I don't know if you know generics. Are you familiar with generics at all? Okay. You're a real beginner in this stuff then, aren't you?
Yeah, I've been in this for like 2 months. So.
Okay, all right. We should probably start you off with the C# basics class then,
Yeah.
instead of this stuff. This is high level design and architecture type stuff.
Yeah, I've been going through a C# fundamentals book, and I just got onto it trying to explain object orientation and stuff.
Uh-huh.
And my dad's like, all right, let's go to this class. And it's like, okay.
You should probably I actually have a C# series on my YouTube channel. Oh look, I'm live right now. Let's see. No, I want to go programming made easy. I have a C# basics course right there. Oh. Yeah, there's about 64 different videos in this that take you through all the basics, including object-oriented. What is object-oriented programming, and what are the 4 pillars of object-oriented programming? And I get into abstractions and stuff like that. So it's probably this type of talk is probably a bit over your head, because this right here, you probably have no idea what any of this is.
No.
I know the first time I saw something like that, I was like, what? That is way beyond me.
No, that's what I'm going through right now.
Yeah.
What I'm used to is the first example that you showed.
Yeah, yeah. Just, so I think let's work through this kind of one thing at a time, and maybe we can get something out of it, because it's a lot to take in for somebody at your level.
I mean, seeing the solid really helped.
Yeah.
Because I got the first thing and a little bit of the second thing that to know. But otherwise, I hadn't gone through the iteration of the whole thing. So it kind of helps to see into the future so you can work your way to it.
Yeah, and architecture is one of those things that the earlier you understand, I think the better, because you have to learn how to organize your code.
Mm-hmm.
I organize my code into what they call feature folders,
Mm-hmm.
So that if I want to go find out how do I get my, get car details. I mean, you can look at the folder structure here: common, get car details, user prompt, and validation. So these 4 folders basically comprise of the different features of my application, right?
Yeah.
And then I have this other thing called startup that's just basically how I bootstrap my application. And all it has is one class in here that basically tells the system it's a class, it's a static class that defines whenever I have this interface over here, I want you to instantiate or new up an instance of this concrete class over here. So everywhere that it's called, I don't have to do any new. Anytime that I inject an instance of that interface, it's going to new up automatically an instance of that concrete class for me. And I don't have to worry about newing it up at all. This service provider is going to do it for me.
So it does the new command without.
Yeah, and it does it from a very top level.
Yeah.
As a matter of fact, my application would not work as soon as I try to run it unless unless all of the dependencies that it needs work together. It wouldn't work until I made sure everything was registered, which is great because now I'm never going to miss a dependency. If one of those classes needs some sort of concrete class, I'm guaranteed that it's going to be there because it won't even work. I can't even run the application until everything is there. So starting with the program class, because this is our entry point, the first thing I'm doing is I'm asking that services class, okay, on that service provider, and this iService provider is an interface that .NET Core actually provides. So one of the functions that's on iService provider is get service. So I could do get service iApplication. Now what if I wanted to do, so I have this application, iApplication. Let's do this. Check this out. So I'm going to take everything that's in here. This is why you do solid code right here. I'm going to create a new class. Call it old app. Okay. So this class called old app, I'm going to have it inherit from iApp. Oops. Oh gosh, I can't type today. So it inherits from iApplication. iApplication, in order for me to implement it, I have to have this run method on it that returns void. Now, so this is my old application. I can just paste how the old application ran. So brand new logic for how my application runs. Totally different, right? I had the one way that it ran. So here's my app call here to the new way, right? The solid way,
Yeah.
right? Notice that it's just asking for the service for iApplication. That's all it's asking for is give me the concrete class that implements iApplication. And then it sets that concrete class to this variable called app. And then it runs it. Now I've created this other app that implements the same iApplication. Okay, so our old application here, our iSolid application, or our solid application, there we go. So our solid application implements iApplication. Now our old app implements iApplication, right? So both of these now implement iApplication. Make sense?
Yes.
And all I've done is in the old app, I've just copied what was in this old application that I got from the old principles demo, okay? I just copied everything that was in this class and I just threw it into this run method. So the entire logic of my application has completely changed, right? The way that my application runs, the entire thing, the logic, everything, the endpoints, all of it, completely changed. All I had to do was, in order to make this new logic, implement it, is go to my services and change from solid application to old app.
So
Now
it
I'm,
changes the cord that's connected to everything.
yeah. So I just completely changed my application with a couple of mouse clicks and a couple of keystrokes.
That's beautiful.
I switched from this logic over here. My entire application, I mean, that's the beauty of it. My entire application was doing this logic over here and ran all this way. So I can literally, I can change on the fly, okay, when this user logs in or when this user comes on, it's gonna be a WPF application. When this person comes on, it's gonna be a console application. When this person comes on, it's gonna be a WSC service. It's gonna be, you can do whatever conditions you want, whatever environment you want. You can use this mechanism to swap the logic entirely. The entire application, not just one little bit of it. But you can do just one little bit of it too if you wanted to.
Mm-hmm.
So I think that's the power of having solid code, is that you can do stuff like this and it'll work. It'll work just like it did before. It's just now that it has the old logic in it, right?
Yes.
And that's going to make it easier for us whenever we need to make a revert back, or if we need to add changes, we need to fix something. We just, okay, new logic, let's put that in.
Mm-hmm.
That make sense?
Yes.
Okay. Anything else you want to see or follow along with, or questions?
I think it would be kind of cool, even though I don't understand what's going on with your solid version of the code.
Okay.
If you could show where the categories lie that you showed before on your slideshow, where it showed, oh, this is the user interface section,
Okay.
stuff like that. You know what I'm trying to say?
Yeah. You're talking about this slide back here.
Yeah. If you could just sort of point and go, okay, this is what the DAL is.
Right, right, the data access
Yeah.
layer. There really isn't a data access layer for this because I'm not storing any data anywhere. So there's no data access layer, but there is a service layer.
Yeah.
Okay, and the service layer is, one of the things that I do is I break it up according to features, not components. This is something you will find the majority of developers, we've gotten in the habit of doing it by component. MVC is an example of model view controller, and right out of the box it creates 3 folders: models folder, views folder, and a controllers folder. Okay, that's the wrong way to architecture your application, because if you want to go find something, where is it? I have to figure out what component that belongs to, and that's a problem. Okay, so what you want to do instead is you want to break it up into the features. So there are some things that are features of the application, some things that help us bootstrap the application. So the startup class, I could have put startup in its own as a feature of the application. That would make sense. But the application folder and where the logic starts for where my application is, that's not really a feature of the application. That's kind of like the starting point. That's the entry point into my application, right? So I have application folder where I define iApplication as the interface, and solid application is the concrete class that implements it. I don't have an API here in this particular case because the user is not really in control. The only things that they're really doing is they're answering the questions I give them, because this is a console app.
Yeah.
So there are no endpoints for the user to come to and ask for a particular set of data and then to do something and then send me another thing. And there's no back and forth here between my application and them. It's just, give me 2 pieces of data, I'll tell you whether or not it's good.
Mm-hmm.
Okay. So it's a very controlled environment, and because of that, we don't really have an API layer.
Okay.
The user interface, I've actually separated off into its own service. Okay, the user interface is a service layer. So if we look at the user prompt, notice that I've called it an iUser prompt service.
Yes.
Okay, the iUser prompt service has a get user input method that takes a string of message text. What is it that I want to tell the user? and then I'm going to get back a string from the user. That's get user input. Get user key is if I only want to get one key from the user. It's a yes or no, right? Yes, I do, no, I don't. So my message is going to be this, and now I'm going to get back a console key, right? So I've got a console key is going to be what gets returned back by the get user key function, and then void post message. I'm going to post a message to the user, this message text, but I don't expect anything back from that method, okay? Now the implementation of this interface is simply this. Here's my three different things. My public string get user, and first and foremost, of course, we're implementing iUserPrompt service, right? So we're saying implement that interface that I just showed you, right? Those are the definitions of what I'm going to have in it. Get user input function gets a message text. What's it going to do with that message text? Well, it's going to write it to the console, and then it's going to return whatever the user puts in for that read line, okay? And that gets returned back out of that get user input. Same thing with get user key. Pass in a message text, write it to the console, and then whatever the key is the user enters at that read key prompt is going to be returned by the get user key function. And then last but not least, the post message. You probably haven't seen this syntax before. This is relatively new. This is called I think they call it the full body member expression, member body expression. Here we go. We call it the arrow syntax in JavaScript, right? ECMAScript 6 guy right back there, right? Arrow syntax. We call it member bodied expressions in C#. So it's just basically this. Take a message text, write it to the console window. I don't expect anything back.
Okay.
Okay, so this is implementing my iUserPrompt service. And I'm just defining how I'm going to interact with the user. That is my user interface. That's it. It's just a service. Now, what are the messages that I'm going to send? Well, that's in a different place because that's not the responsibility of the service.
Right.
The service doesn't know what I'm going to send it. All I've defined is that it's going to send it. There's my next interface. I get card details orchestrator. So this is one of my orchestrator classes. This is where the business logic starts at, right? An orchestrator class is the entry point to my business rules. And it's defining that there are two methods on this orchestrator. Get vehicle make, get vehicle year. Both of them are going to return a string. I don't have to pass in anything to these functions, okay? They're going to be predefined on the orchestrator that implements me. So how is that implemented? Simple. Inherit I get card details orchestrator first. I need to pass in an instance of that user prompt though. Right? That user prompt service that I just showed you.
Yeah.
I need to pass in that as a service because I'm going to need to use it. Right? In order for me to pass in this text to the user, I need that service layer. So pass it in as part of the constructor of my get card details orchestrator. Does that make sense? Okay. How this user prompt service back up here, gets injected into the class. So how this user prompt service gets injected into my orchestrator is all handled automatically by my inversion of control container, where all those services were defined that said if I need an iUserPrompt service, send it a userPrompt service class. Okay, all that is all pre-handled. So now I'm going to get an instance of something of iUserPrompt service. It's going to be assigned to this private variable called userPrompt. And now here's the two methods that I said I would have on anything that implements iGetCardDetailsOrchestrator. There's my two methods that I said I must have on this iGetCardDetailsOrchestrator. Those two methods, the first one, getVehicleMake, on the user prompt, get the user input, calls the get user input method on that user prompt, and just passes in, please enter the make of the car. Okay? And then it returns back. So whatever we get out of this get user input method, we know that it's going to be a string that gets returned back. Well, just return that string from my get vehicle make. And then the same thing with the get vehicle year. It's the same thing, right? So ask my user prompt service to get the user input after I put this in. And then just return that to whoever's calling me. I don't even know who's calling me. I don't even know who wants this information, but there it is, it's been defined. There's my business rule that implements a service, right? Takes a service through the constructor, calls the different methods on it. Is that making more sense?
Yeah, it's making more sense.
Okay.
I'm getting the ideas you're portraying. I'm
Okay.
not capturing all the specific words. And so
Okay.
that's how it's been going.
No problem, no problem. This is, for somebody who's only been doing this a few months, yeah, this would be a bit overwhelming. So there's my domain layer, right? My orchestrators,
Yeah,
okay? You've seen also my service layer.
yeah.
And really, there's not much more to this application because there is no API. There's no need for an API. There's no data access layer, right? There's just the services that it provides. And the services that it provides are also where I send out the data. So I don't even have a view to send out. I could split that up. I could, but there's really no need to because there's such small enough pieces of information about what I'm sending to the user and expecting back that I don't need to break that out into different responsibilities. It can be one responsibility. So that's...
So it takes a much more sizable, I guess I'll call it app, in order to implement all 5 of those categories.
Right. And that's why I'm saying the architecture will get borne out just by following the single responsibility principle. You don't need all these layers. Right? I don't need, for this small of an application, it doesn't make sense for me to have all of that.
Yeah.
Where did you go? There you go. It doesn't make sense to have an API, a domain layer. I need the domain layer. That's a given. But the UI, for this small, maybe not. For the data access layer, probably not. But that's just going to come about because I'm following the single responsibility principle. You guys can come in if you want.
Yeah, we're taking a break, so we're
Okay. Is it taking a break? I'm already done with my talk, but we're kind of going back over some stuff. So yeah, the domain layer is obviously something you're gonna have because that's got all your business logic in it. But all this other stuff just comes about because as you need to split things off, you'll be creating the layers.
And it just does it on its own by following solid.
Yeah. Just by not even just solid, but doing
Single
this.
responsibility, yeah.
Just by doing that. You'll start to form, okay, this is a different responsibility. I need this class to do this. Well, okay, that's a different responsibility. I'm naming that responsibility as service. The responsibility of that is a data access layer. The responsibility of that class is the API. Okay? The responsibility of that class is an orchestrator. I call it an orchestrator, you can call it whatever you want. That's just what I like to call it. Because I like a single point of entry that basically defines, it's kind of like an API for my business rules. Right? That's essentially what an orchestrator is to me. It's an API for my business rules. So that I know what I can call and what I can expect back from my business rules. So that's just what I like to do. You can call it whatever you want. Like I said, other people call it an interactor. Some people don't even have this kind of top layer of your domain logic. They just call whatever they need, but then they're not really following very good layering. So
Okay.
all right. So yeah, my application doesn't have all this stuff in it. This is what you would see in an MVC application.
Okay.
This would be borne out based from that. Because you would theoretically have some sort of database. You would need some sort of way to connect to that database, so you would need a repository or a service that connects to that database. Then you have your user interface, your views. You would need that obviously for a web application. You'd have your API, which are the endpoints, which is where you get called. I mean, this is a requirement of an MVC application, this part here. I've just split it up because it makes more sense to me to split those up instead of trying to do it all in one controller. That doesn't make any sense.
Yeah.
All right?
Where'd you say you had this entire PowerPoint?
It's on the GitHub. If you go to the GitHub, do I still have viewers?
You do, but your screen went black, so.
Oh, that's weird. I think it's probably because I'm not doing the, it probably still has me on camera, right? But it doesn't have
Yeah.
the screen?
Yeah.
Yeah, I think that was when I,
So they said, hopefully he puts the other stuff on.
that was when I tried to do the split screen.
That's what I told him. I said, I think something happened when you did the split screen.
Okay.
See, I'm smart. I can convey what happens to people.
Display. It's because I did this duplicate.
Yelling.
See, there.
There you go.
Yeah. Only trouble is I can't really see it on my screen when I do that. But oh well. Okay. So yeah, probably all my viewers are gone anyway. I don't know if anybody's still watching.
There were 8 when I looked.
Oh wow. Okay. Well, those lucky people. Now they get to see my actual code here.
7.
Wow. I'm down to 7 people. That's more people though than I have in this room right now. All right. So
Could I see your GitHub URL
yeah,
again? I didn't
GitHub. You're right.
catch that.
Let's do the GitHub thing. GitHub.com/XIP000/solid principles demo. And that's got both the terrible, horrible, non-solid example and the solid example.
Awesome. Because while I am not entirely syncing it in now, I know if I hold on to this,
Yeah.
I can use it in the future.
Yeah, because you're going to be able to look at the code and you're going to be, oh, that's what we were doing.
Alright, so github.com/XIPOO/solid principles demo.
Yep.
Alright.
Joe McVicker. So yeah, these dependency rules, I mean, you'll just notice that everything, this is the key part to remember. Every one of these constructors, in order to figure out what to do on these functions, it needs something, right? In order for this getVehicle method to work, it needs some sort of service to prompt to the user. And so I'm injecting into the constructor of my class an instance of something that implements IUserPromptService.
Yeah.
Okay? And now, as far as the getVehicleMake method is concerned, it doesn't know what the actual concrete class is that does the user prompt. All it knows is that it can call the getUserInput method. That's all it cares about. And then it knows that it can pass it in a string. Because we've defined in the IUserPromptService, we've defined that. This is going to be tricky. IUserPromptService. We know that we have the getUserInput method that takes a string, a message text as string. And it's going to spit back out a string. I don't know how it's going to do that. I just know that it will do that. Okay? And the way that we implemented that was through this class, which implements IUserPromptService. So we're defining those are the 3 methods that must be on there. There's my getUserInput method. It takes a message text, sends it to the console window, and returns back a string. So I've created a contract with that IUserPromptService. I've created a contract that UserPromptService is saying it agrees to implement those things. And it requires these things. Does that make sense?
Yes.
All right, good. Interfaces are so cool. They're so cool.
Yeah, I've never touched interfaces before. I got an introduction on the way here in the car.
Yeah.
So yeah, this looks like something, this is really nice actually. I've been looking for something like this that sort of pulls a lot of stuff together so that I can reference what I'm doing.
Yeah. Yeah.
So this is beautiful.
Good. Good.
Oh.
Go ahead.
Sorry, I do have a question about the, I guess you call it dependency injectors?
Yeah, dependency injection.
Dependency injection is, so is that kind of implying that there is like some minimal amount of dependency just a way so that it can depend but it's not dependent?
You're abstracting away the dependencies. Essentially, this service class, if we go to the services class, this class contains the definitions of what will need to be injected.
Mm-hmm.
Okay, so we're saying, so this startup class, or the services class in my startup folder, I have just a simple iService provider interface. This interface is created by Microsoft. Okay, I did not write the iService provider. I did not write the service collection method or function class.
Mm-hmm.
Okay, so I'm newing up an instance.
Mm-hmm.
I fully admit this is not solid.
Yeah.
But that's because this is the one and only place that I need to do this. And this is really just a management. This is like a registration. I'm registering that if iApplication gets called, use this concrete class. If iSolid Application Orchestrator gets called, this is the actual concrete class that I need to use. You see how that works? So there's my interface, there's the concrete class that's going to be actually used.
Yeah, I just got it a little bit better this time since you did that.
Yeah. I use a prompt service, there's my prompt service, right?
Mm-hmm.
And what's cool is I only have to define this the one time.
Yeah.
And then throughout my entire application, this service collection will find all of those spots where I'm injecting it and find every one of them and implement my concrete classes for me. So I never have to new up anything. This is the one and only time I ever do.
Now I get it. Oh my god. This is where the abstract and concrete hold hands.
Yes.
Through the whole thing.
Correct.
Okay.
Yes.
Okay.
This services class is precisely that.
Okay.
This is the definition of any time that I have an interface that is needed somewhere in my application, this is the concrete class that gets put in its place.
This is the middleman.
This is the middleman. And it's all in one class. It's all in one method. Again,
Yeah.
one page.
Mm-hmm.
One page. Obviously, as I get bigger, this is going to get bigger. But if it gets bigger, I can split it up into other classes because those responsibilities are starting to get bigger, right?
Mm-hmm.
So as soon as the responsibility of this service provider gets bigger, split it up into its own class. Maybe start grouping some of these things. Some of these are services. Some of these are features. Some of these are user inputs. Some of these are, so you can actually start grouping those requirements into their own classes and then just calling them here inside of the service provider. But once you do that, it's really neat, right? Because now this is the only place where I ever have to define what concrete classes I'm going to need anywhere in my application. Anywhere. And now I'm just passing everywhere in my code. Not necessarily that one,
You're just
but there's my
loading up the
orchestrator.
interface?
So my orchestrator, my card details orchestrator, it needs a service. It needs that user prompt service. It doesn't care what concrete class it is. All it knows is that there's an interface of iUser prompt service. That's all it knows.
Yeah.
And it's going to use it and call the methods that are on it.
Mm-hmm.
I can delay, I don't even need to know what that get user method input does. I can leave that up to the class that I'm eventually going to create that implements that interface. It's cool. Now everything is swappable.
Yes.
Every single part of this is replaceable. Every single part is replaceable. I just showed you. I can replace the entire application. The entire application I can swap with just a few clicks of the keys and a mouse click.
That is pretty amazing.
Yeah. And that is not something that you're going to typically find out in the work environment.
Mm-hmm.
That is the complete opposite of what you're probably going to find in the work environment.
It's what I'm gonna find. Example A is what I'm gonna find her.
Tell you what, I'll give you a bonus.
Okay.
I'll give you a bonus.
Because I do want to really get the hang of this full stack engineering.
Yeah. I did this talk 2 months ago.
Mm-hmm.
You want to hear another talk?
Okay.
Okay. This one is a little different. So all you guys on YouTube, you've already probably seen this talk, but I'm going to give it again because she's been real nice and patient with me. So you know all this good stuff, all these details. Mpemba effect. Mpemba effect. You ever heard of the Mpemba effect? Okay. There was a little 12-year-old Tunisian boy, and he's going to school. And one of the things that the school is doing is they have a cooking class, okay? And this cooking class has many different activities that it does, but one in particular is making ice cream. And what 12-year-old boy doesn't like making ice cream? So Erasto, the night before, was supposed to get some cream for doing the ice cream, and he forgot. So he had to, on his way to school, go to the store and pick up some of the cream to make the ice cream. Now, this was back in the 60s, I believe it was, if I recall correctly, 50s or 60s. So he takes, the way that you made ice cream back then, especially in Tunisia, was you take a giant bowl. Yeah, I'm redoing this one, I know. You take a giant bowl and you put sugar in, you put the cream in, and you just boil it up. You get it really nice and hot. And whatever other flavorings, like vanilla or chocolate, whatever those are, you stick them in there, you get it all boiling up, okay? And then you wait until after you've done mixing it up, you wait till it gets down to room temperature. Then after it gets to room temperature, you take that bowl and you stick it into the freezer. Now, Erasto was late to his class because he had to stop by the store and go pick up his cream. And in the school that he was at, there was only so much room in the refrigerator or in the freezer to stick your ice cream. And he had other boys in the class that he was competing with, and he was already late. So he's hurrying up, he's boiling it up and mixing it and mixing, and he's really late. So he has a choice to make, because he's supposed to wait till it gets cooled down to room temperature before sticking it in the freezer. But all the other boys are starting to get done. Theirs is already cooled down to room temperature. They're starting to put theirs in the freezer. So there's only so much room. He decides on a whim, I'm going to take this boiling water, I'm going to stick it in the freezer along with everybody else, the boiling milk. I'm going to stick it in the freezer at the same time as all these kids, which is really, really dangerous. Really dangerous to do. Because not only do you increase the temperature inside of the box, which means everybody else's is going to take longer, but also you could possibly break the freezer, because these are very temperamental things back in the 50s and 60s. So he's taken a real big chance, and after about an hour to an hour and a half, he goes at the same time that he put his bowl in, there was another boy that put his room temperatures in. Okay, so they both simultaneously put theirs in at the same time. Hour and a half comes around, they both go up, they both pull theirs out, and Erasto's is more frozen than the other boys. His bowl of cream was more frozen than the other boys. And this perplexed Erasto. He could not figure out why this happened. And after some time, he does more experiments. He tries it with water. He tries it with all sorts of other types of liquids. And time again, he discovers, sure enough, that hot water freezes faster than tepid water. So then he goes and he eventually goes on to university, and he asks the science teacher there, why does this happen? And the science teacher laughed at him. Could not believe that this kid would even, he did it in front of the class too. So this was like really humiliating. Class laughs at him, the professor laughs at him. No way, this doesn't actually happen. But the professor wanted to humor him. So the professor goes and does his own experiments on his own time. I'm doing the agile talk now, because why not?
It's a good one.
So why not? So anyway, the professor decides to go and try to recreate the circumstances anyway. And what do you suppose he finds?
The exact same thing.
The exact same thing. This completely perplexes him. But what does end up happening is both of them write They co-author an article that is peer-reviewed, and now it is official science history that Erasto Mpemba has an effect named after him where hot water freezes faster than tepid water. Have you ever heard that before?
I have never heard that story before.
Yeah, so that's where we get that from. Anyway, so that's not what we're here to talk about. We're actually here to talk about agile thinking, a different perspective. So, planning our projects. The problem. We suck at it, right? We suck at it. Now, we think we're awesome at it because we're just that way. We think that we're great at this stuff. This is what we do, is we're great at it. But we miss deadlines, we rush, we don't test properly, we write stuff that doesn't work, we write more stuff than we need, we don't give the customer what they want, we can't change things after they're implemented, we organize our code very poorly, and we give bad names to things like public, void, the function that does stuff but I don't know how it works, int p. Any idea what that does? It does stuff. And it takes, what kind of integer? P. I don't know what that's supposed to do. All right, so the result of this is that the client expectation is a nice dish of ravioli, everything nicely presented and kind of modular in the way that I can just eat this piece individually. But what they actually get is spaghetti. Oh, you wanted features. Well, there you go. There's your features. Right? That's what we do. We do that. We build code base, it's spaghetti, and then we just kind of throw on whatever we can as we need to.
Is that ketchup?
Yeah. So what do we do about this? Well, Agile has 4 core values. Okay, it is not a process. If you ever hear the term Agile and somebody says, "Oh, Agile, we do the Agile process," no, there is no such thing as the Agile process. There are only values. There's also 12 principles, but the 4 core values are what I'm going to talk about. Individuals and interactions over process and tools. Working software over comprehensive documentation. Customer collaboration over contract negotiation. And responding to change over following a plan. Now what we're saying is that while there is value in the items on the right, there's value in those things. We value the things on the left more.
Okay.
Okay, individuals and interactions are more important than process and tools. Working software is more important than comprehensive documentation. Customer collaboration is more important than contract negotiation. And responding to change is more important than just following a plan. Okay, make sense? So if we did these things, if we did value individuals and interactions over the processes and the tools that we use, what would be the results of that? What would that look like? Well, we'd better utilize the strengths of the team, right? Because we're getting to know them. We understand what their strengths and their weaknesses are, so we're going to be able to better utilize those things. We're going to be able to plan things better. We're going to be able to assign things or have other people do things that they're better at. You're going to get new ideas because you're talking about things. You're having these interactions with one another to come up with these new ideas about how to do things. And it's going to be easier to help each other because you get to know each other much better. And this is working in our own environment, right? This is working with other people that you work with. You're going to be able to help each other more. You're going to have these new ideas. You're going to be able to plan amongst yourselves better. You're going to be able to better utilize the strengths. And then, of course, there's going to be some accountability because now that you guys are talking about what you guys are doing, you're going to start to feel beholden to them. You've told them you're doing something, now you're going to have to do it.
Yep.
Better naming conventions and programming style because others have to read it and they're going to tell you when you've done it wrong. You did this and I have no idea what it's supposed to do. I did the function that does stuff that I don't know really what it does in P. Yeah, well, we're not going to be able to do that because other people are going to go, what were you thinking? We need to come up with something better than that. So we agree upon some sort of convention and some sort of programming technique or style.
And this is why Git has come along then, for this, more or less.
Git is source control, so it's a
Yeah.
way to collaborate. But
Yeah.
that's the tooling. That is not agile, that's tools. That is a tool. GitHub is a source control, which is a way of doing the collaboration as far as sharing your source code between each other. You split it, you fork it, you allow other people to work on their sections, and then you merge the the projects together back into one.
Yeah,
So
I'm
that-
just saying it allows for interactions on the web, right?
GitHub allows you to do like open source and stuff, so people, you can post your code up online and then they can do it, but Git itself is a source control. I might have mixed it up. I thought you said Git, but you said GitHub, didn't you, originally?
Yeah.
Okay, I'm sorry. Yeah, GitHub is basically like a way to post your code online for other people to look at, or you can make it a private and other people can't see it. But it's really a way of backing up and storing your code.
Mm-hmm.
And then every time you make a change, you can commit it to your local system and also get posts up onto the internet. So you can either make that internet version public so other people can contribute, and then you can pull their version down and see what you want to integrate with your code.
Mm-hmm.
So it's just a collaboration. Yeah, it is a way to collaborate between other people, but it's the tool that does that, right? So it's the tool. We're really looking to have direct interaction, direct individual interaction, because we don't want to rely upon the tools to do this for us. I want to get on a phone call with you. I want to get, I want to do a Skype call with you. I want to sit down and talk to you about things. I want to talk in the halls with you. I want to have direct communication because that is more important than using a tool to talk. Does that make sense?
Yeah.
Okay.
I was just wondering if that is one of the things that it was trying to solve along with sharing the code.
Somewhat, yeah, somewhat. It's more of the tool though. It's
Okay.
not really, it's not specifically for the, I would say it's not, it is the tool that allows people to collaborate as far as integrating code, but
Mhm.
nothing beyond that.
Okay.
For you and I to talk in a conversation a week from now, GitHub doesn't facilitate that,
Mhm.
right? We have to decide, I'm gonna open up a spot on my calendar on Friday at 2 o'clock for you to come down to my office and talk. That's the type of thing that you have to do. You have to have that collaboration. So in order for us to do that, in order for us to emphasize individual interactions over the processes and tooling, daily we should be discussing progress. Daily.
Mhm.
That's really what we should be doing. Where are you at on things? Where am I at on things? They call these stand-ups. They call them stand-ups because I guess you're supposed to be standing the whole time. You're not supposed to take very long. These stand-ups daily are not supposed to be very long. If you have something that is a more in-depth discussion, you do what we call parking lot it. You park it. You say, let's take this to the parking lot. And the idea is if you have a more in-depth thing that you need to talk about, let's not do it right here, right now with everybody around. Let's go kind of in our own little corner, either a little corner office or even better, let's go out to the parking lot and talk about it.
Mhm.
Let's get away from our environment, kind of a neutral ground where we can just hash this over, okay? Paired programming is another thing where basically you sit with someone else and you both program on the same screen together. Okay, and you talk about things. One person's looking over your shoulder telling you, I wouldn't do that. That sort of thing.
Mhm.
Use communal areas. Like, there's places out there, there's hallways, there's cafeterias, there's parking lots, there's wherever everybody else is, everybody should be going there. Let's get together and group together to do our code, not sit in our cubicles and just try to isolate ourselves from everybody else. It's often very helpful if you can have that person right there that you need to ask that question.
Yeah.
If you're not having that communal area and you're isolating yourself, it becomes very difficult for you to have those interactions. And virtual ones work too. Virtual communal areas. Skype. If we've got it, why not use it all the time?
Mhm.
Why do we turn it off? Why not keep it on?
Right.
Just because we're working and, the other person's working and gets up from their desk, is that a reason why not to have Skype still on? Not really. If you don't want somebody to see something, just cover up your camera or something like that. I don't know. But at least if you keep it on, you can, at a moment's notice, talk to that person, just as if they were right there with you. Now, per iteration, this goes back to Agile, and we'll talk about iterations a little bit in a little bit here, but per iteration, you should be recapping your past successes with each other. Everybody loves attaboys, right? And good job. You know what? You did a great job with that service, the integration with the credit card system. You did a fantastic job with that. We like to hear that we did a good job. So definitely recap those successes for each iteration. And then you should be doing some self and team assignments of the next upcoming features. Instead of having someone up here saying, you do this, you do this, you do this, it's much, much better if people say, all right, so we've got the credit card integration, who wants to take that on? Why don't you work with Cindy? I know that you guys worked together in the past, why don't you two take it up? And now they're buying in. It's not me assigning it to them, it's them taking ownership of that feature. That's far better because they're gonna feel comfortable. They're gonna feel like, I'm going to do this, this is what I want to do, now I'm taking on the features and doing the things that I want to do rather than, I've been assigned to do this and I don't really want to do it. If you can get the buy-in, that's always better.
Yeah, choose that attitude.
Yeah. Okay. Next, working software over comprehensive documentation. If we emphasized working software, if that was our goal, more than it was to have comprehensive documentation, what would the results of that look like? Well, for our customers and our users, there'd be positive reinforcement. Because every time that we deliver a product, it's working. Mm-hmm. Every time we deliver a product to the customer, it's working. How much faith are they going to have in us now?
Infinite.
It's going to be a lot better, right? And they're going to see some visible progress. They're actually going to be able to see every time that they get it. They're not going to see, if I try to demonstrate something and it doesn't work, are they seeing progress?
No.
No, they think that nothing has been progress. So it gives them visible progress. Foundation for communicating future planning. This gives you a baseline to talk to them. This is where we're at. This is where we're going. Mm-hmm. You can see and handle what we've done. You can interact with it. You can see. Now you just imagine on top of what it currently does, this is what we're going to do next. Now you have that baseline to talk to them about the future planning. Okay? And your coworkers, how would this affect your coworkers if you were making working software every time? You'd have tangible milestones, because no longer does this seem like a big infinite project that's never going to end. Because if you're trying to get working software each iteration, each little time frame that you're setting this up as, that means that in order for me to get there, I have to have some pretty concrete steps that I'm going to have to accomplish first to get this thing done and working, right? If I don't have those milestones, I can't get to working software.
Yeah.
I'm going to have confidence in my abilities and in the software. I did it. I'm going to continue to do it. Mm-hmm. I know I can do it. I've done it. The software works. It works. I don't have to worry about it anymore because it works. Mm-hmm. I don't have to worry if it's going to break on me because it's working, right? If I add something new, I already know that what was already there is working, so I can always revert back to that. Mm-hmm. But I also gain confidence in my abilities to do those things too. It also means that you're going to have more thoughtful development, because in order for me to get to working software, I better think long and hard about what it is that I'm currently doing. If I'm working on some high pie in the sky thing that I plan on implementing 6, 7, or 8 months down the road that's not even a part of this iteration that's been defined, and I'm trying to do all sorts of other things because I like it, it's cool, it's awesome, I love this new technology that I found, but the problem is it doesn't really get me to working software. I need to be more careful about what my decisions are as I'm doing my development. I have to think about it. Is this going to help me get there? Mm-hmm. If I do this, does this make my life more complicated, or does it get me to working software? Right? That's a decision we should always be trying to make, is that we get to working software. It also gives us better time management. short, easy deadlines, okay? Because if we have working software that we're trying to reproduce over and over and over again, we're gonna really think about how we're using our time. And then time requirements become more measurable. Our time requirements, we're going to be able to understand each time that we produce some piece of working software, what did it take for us to get there? We can look back and say, how long did it take for me to implement X, Y, Z? Okay, that's about how long I think it's going to take me to implement this new feature, based upon previous things. My time requirements become more measurable because I have a baseline with working software that I've already produced. So how do we get there? Well, we need to develop in small iterations, okay? Not big ones. And we need to define done. What does done mean? What does it mean to have working software that's done?
All loose ends are tied.
What does that mean?
The user can use it from front to back.
Okay, so you have user acceptance testing. But what about delivery, deployment, QA testing? Have you done any of that maybe, right? There should probably be a QA step in there somewhere.
Yeah.
So we need to define for each time that we do an iteration, what does it mean to be done and having working software? Okay? So what is done? What about testing? What about deployment? What about packaging? How are we packaging this? Are we putting it on a DVD and distributing out to people like Windows 95 was back in the day? Or, actually that was on CD anyway. Or is this a deployment package that goes out online? And are we even saying that this packaging is even part of being done? Sometimes we don't necessarily want to have an external, we're not actually going to package it. We're just going to say it's done internally. This iteration is done and we're not deploying it. That's possible. It happens. And then what about versioning? You might need to do some versions, right? So change the versions of your code. And then what about any documentation you might need? Would that be part of what you need to have is done? Do you need to document certain things that you've implemented? Maybe that needs to go into how you've defined done. Because maybe you've got all these things done, but you haven't put any documentation, so the user doesn't even know how to use what you've done. So maybe we need to include documentation as part of what done is. Okay? Customer collaboration over contract negotiation. What would it look like if we emphasized the customer collaborating with the customer? What if that was our primary emphasis and we weren't as concerned about the contract negotiation? Well, we definitely have a better communication of ideas because they wouldn't feel hardened, they wouldn't feel like they are strapped to that contract and they can't talk about anything that goes beyond that. If you feel like you have a collaboration with them, they're going to feel open to telling you their ideas and you're going to be open to tell them about your ideas. You're going to have better understanding of what the user's needs are because you're talking about it. What do you need, right? And you're going to start to plan from the perspective of the user. If every time that you ask the customer, what do you want? They're going to tell you what you want, what they want, and you're going to be able to start seeing things through their eyes. How do they want it to work? And when you understand how they want it to work, you may not be able to figure out just yet how it's going to work, but at least you understand what they're getting to, what they want.
You got a point B.
Yeah. Easier to discuss potential risks and rewards because now, once the customer starts to see working software, okay, and they start to see where the project is going, and you're talking to them about these things as you're going along, they're going to start to see some of the risks and the rewards for the next stages. Sure, we could implement this for the web, but I think you know that if we do that, it's going to raise some security issues. Okay? We've already had problems with security in the past. Doing this step might add some additional security issues that we're going to have to be concerned about. That's a risk. But the reward is that now we have web presence and customers can access things, or our employees or whoever can now access those things via the web. So that might be a reward, but it's easier to discuss those things because you actually have some collaboration going on here. You start to actually talk about these things, and they start to understand what you're doing, and you understand what they want. And then this is the doozy. This is the big one that we all want. Fewer ambiguous questions and incoherent results. Because if you are collaborating with them, how many odd, strange, bizarre questions are they going to come up with out of left field? If you're constantly talking about these things, you're both on the same page, how many ambiguous questions are you going to get?
They're not going to be able to throw you off.
No. So how do we do that? Well, regular meetings. Regular. And I mean regular. All the time. Talk to them. In person, preferably. That's the best, to do it in person. Conference calls are okay, preferably with video though. See them, let them see you, okay? Make it as in person as possible, even though you're doing it through video. Email, you could do it through a phone call, obviously, but email is a last resort. The email that you use should probably say something like, hey, can I get together with you on Tuesday? That's what email should be for, is to set up one of these meetings. I want to get together with you.
Because otherwise there's too much room for miscommunication.
Email is good only in doing that, and occasionally I would say sometimes you need it in order to say, I'm going to recap what we talked about, right? Then you have some documentation essentially of what was discussed. That's always good too, especially if there are some issues with contracts. Now, per iteration, we should be talking to them. So we should have regular meetings, preferably at least once per iteration. We'll talk about iterations a little bit later. You should be doing demonstrations with them. You should be demonstrating the product all the time and collect bugs from them. Okay? So these are the things that we're doing with the customer. We're meeting with them regularly. We're doing it at least once per iteration. We're doing demonstrations with them. We're collecting bugs. We're going to discuss upcoming features of the application. And we're going to seek advice from them. Hey, what could we do better? How would you handle this? What would you like to see done? And finally, make user stories. Have you ever heard the term user story?
No, but I gotta guess.
A user story is where you get, how is this feature going to be used by this person? How is that person, that particular type of person, going to use this feature? And you write a little story about how that's going to happen. This user will, as a manager, I will be able to do this with this feature. Does that make sense? So make user stories. And we'll come back to user stories a little bit later, but this is what you're doing when you're collaborating with your customer. You're doing these things. You're doing your meetings in person. You are doing it at least once per iteration. You're doing your demonstrations. You're getting your bugs from them that you might have missed. You're going to discuss with them any upcoming features. You're going to ask them for advice. And then you're going to make your user stories from what their description of how the application should work. Now finally, responding to change over following a plan. I love this little image over here. Does this spark any sort of emotion to you when you see an image like that? Are you proud? Is this like, for this guy up here, he's leading the way, he's leading the charge, and everyone's following in his direction? Is that what you see?
Yeah.
Or do you see all these poor schmucks that are holding him up as he's making...
That too.
That too?
It's
Yeah.
up to interpretation, depending on where you're standing.
Yeah. So, responding to change over following a plan. If we were able to respond to change, instead of, and that was our emphasis, more than just following a plan that we previously devised, what would that look like? What would be the benefits of that? Well, software would be made that is easier to work with because it's less brittle. If our code could respond to change, then that means it would be easier for us to work with and make changes, right? If we were able to respond to change, then we would have better time management because now we don't have to spend so much time. You saw the chart that I had in the previous talk about all the time that's dedicated to fixing broken code,
Yeah.
right?
with
Old
the
code,
iterations.
legacy code,
Yeah.
as you go through. So your time management becomes better because you can actually make the response. You can respond to things that are changing in the environment. Debugging is way easier because, again, if you have siloed classes, right? Trying to figure out where the problems are in your application, you find it to that one class that's broken, and then you fix it and you replace it, right? And
Yes.
as we talked about with interfaces, if you implement the same interface between the two, but you fix the logic, boom, there it is.
Yeah.
You've fixed the problem,
Yeah.
okay? It makes it real easy to debug. You write less unnecessary code because in order for you to respond to change, if you write a bunch of code that is pie-in-the-sky features that haven't yet been implemented, how are you going to be able to respond to change? Right? If I write this thing, I saw this thing on, if you were to say, I saw this thing where Fluent APIs were so much better and I loved them so much, so I'm going to rewrite everything to use Fluent API instead of the traditional way that I expose my code. Okay, so you're going to go through and you're going to do all that. Now you have to go find all the places in your code that you're going to make that change, and now something happens where the manager says, wait a minute, no, we don't really want to do that. Now we have to change again, and you've just wrote all this unnecessary code, and you're not able to respond to that kind of change. To when somebody wants to make a change, it's going to be harder for you to do that if you wrote all this extra code that you have to go and fix and find and replace and change because the requirement changed. Okay, does that make sense?
Yes.
And then code is easier to test because this is kind of a byproduct of what we were talking about in the previous discussion, where when things are isolated like that, you can test those things in isolation. Does my code work exactly the way I want it to? Okay, it does, great. If it doesn't, then I need to fix it or replace it with something else. And by doing that, by having that kind of thing, it means you can quickly respond to change. The customer requirement is that I no longer go to this database, I go to this database. Okay, I just need to change one class to do that. Okay, I respond to that change, but my code is easy to test because I can, with that code being able to be changed and swapped out like that, it's in small little tiny units that only have so much code that I need to test, right?
Yes.
Okay. So how do we do that? How do we get to where we are responding to change better? Small iterations, I say 1 to 4 week cycles, okay? If you have a larger, this is obviously depends upon the number of resources you have available. If you have a whole team, you could probably do a lot of stuff in 1 week.
Yeah.
If you're just by yourself, 4 weeks is probably a more likely goal. But really you should be doing some sort of iterative style. And again, we want to get to the point where we're done. At the end of that 4 week cycle, or whatever this iteration cycle is that you have, it's done.
Yeah.
Okay, it's released, it's ready to go, it's out the door, it's got the documentation, it's been tested, everything. It is done within that iteration. Use abstract classes. This is the only way you can be responding to change, is to use abstract classes and interfaces, okay? Solid principles. That's another way to be able to respond to change, right? Single responsibility principle, open close principle, Liskov substitution principle, interface separate. I said separation, it should be segregation principle, and dependency inversion principle. So there's your solid. Make unit tests. Okay, unit tests. Do you know what unit tests are?
I've done those before, yep.
You've done unit tests? Good, good. Don't stop. Unit tests are so, so beneficial. If I can click on a button that tells me green light, everything you wrote is good. Then I go make a small change and I hit that button again and it's green. How do I feel?
Confident in what you've done.
Confident in what you've done. If it turns red, I know immediately what I just did, where that is that I just broke it, right? Okay, so if I make unit tests that constantly are watching over my code base, and every time I make a small little change, I can easily detect and identify where exactly that is, and now I can respond. I can make changes very easily. Whenever I make this little change over here, I know how it's going to affect my code and whether or not it works. And if I know that that little change that I make is going to work, that means I'm responding to that change as it happens. Test-driven development for the win.
Huh?
Have you heard of test-driven development?
No, but I've got a guess for that too.
Test-driven development means you don't write a single line of production code until you've written a test that's broken first.
A test that's broken first. Okay.
Yes, you write a test for how you want that code to work before you write the code that works. So you write a test, I want to pass in this, I want to get this back. Okay, if I run that test right now, as I just wrote it, it's broke because that doesn't exist yet. So write my code, now fulfill that requirement, now test it again, okay, yes, it works. And then you have a third step, which is refactoring, which is, okay, now that I've got a test, and I've got the code that works, is there anything I can do with this code to make it better? That's a refactoring phase, okay? And ideally, you always want to be refactoring towards the open-close principle. How can I make it more open for change? Or I mean, open for extension, but I don't have to change it. Okay, and you don't really bake that in until the end of the iteration. So feel free to make changes to the classes that you're working on, and then once you do it in an iteration, it's done. You should not be making any changes to that class anymore. But test-driven development is a way of basically doing your development. It's really, really cool. I highly, highly recommend doing it. The only problem is that you can only do it if you're confident everyone else working on the project is doing it at the same time you are. It's because you're trying to basically create test coverage. You're trying to make sure all of your code is tested. And if you're doing it, you're confident in your code, but what about their code?
Yes.
If they're not doing any unit tests, just because my code works doesn't mean it's going to work with their stuff.
Yeah.
So you really need to have everybody on board doing test-driven development for it to really be an effective tool. But if you can do it, absolutely you should do it. You will save yourself time in the long run. Again, very similar to that chart in the other thing. It takes less time to find and fix broken things if you know exactly where everything is broken, because the test tells you.
Yeah. So that's awesome to hear, because the way I've been doing it is just sort of one method at a time and then writing the test for each method.
Do it in reverse.
Yeah, and I can just do it in reverse. And
Yep.
I didn't know if there was an order to it at all. So this is good to know.
Yeah, do it in reverse if you can. Write your test, run it. Okay, it's broke because obviously I haven't written that code yet. Go write the code, run the test again. Okay, it works. Refactor, change it up. Okay, make it a little bit better. Okay, that works good. I didn't really need to do anything, maybe. Hit that test button again. It's still green. Good, my little refactoring works. And then you just do it over and over again. And you just keep making another test. Okay, my test doesn't pass because I haven't written that code yet. Okay, go write the code. Okay, I've written the code. Does it pass yet? Yes, it does. Okay, now go look at the code again and refactor it again. Maybe something's changed. Okay, I'll maybe make my changes, go hit the test button again. Sure enough, everything works again. Okay, build another test now. And it's just one test after another before you write your production code. And write only what you need to fulfill the user's story. Write only what you need to fulfill the user story. Nothing more, nothing less.
No
Okay.
pie in the sky.
No pie in the sky. Make the code better than how you found it. They call this the Boy Scout rule.
That's exactly what I was thinking of when I heard
It's
that.
the Boy Scout rule. Always leave the code better than how you found it. Pick up your mess. Pick up other people's messes. Okay? Make it better. Because when you do, it's going to be easier when the time comes for you to be able to make changes. Write clean code. If you don't know yet what clean code is, I highly recommend you go check out Anything and Everything written by Uncle Bob Martin, Robert C. Martin.
Uncle Bob Martin.
Uncle Bob Martin. I'm giving another talk if you want to sit. Agile.
How did it go?
Well, it's not done.
Oh,
But
are
I
you
knew
still
that
doing
my daughter was waiting on me, so
Oh.
I come in here and let her know that.
Well, I'm
my
pretty much.
laptop once again self-imploded.
What, you it self-imploded again?
My laptop, like
Uh-oh.
it cannot last 10 seconds of that battery. I'm not
You
touching
got
it.
you got a power cord.
Yeah, I got a power cord.
There should be an outlet, Rick. Oh no, they got that
Yeah, they
blocked
got it
off.
all.
Oh dear.
Um,
They didn't want people plugging in over there apparently.
Here, I got an idea.
There's one over there though, way back there or over here.
but you sit
I
in
could
the very
just put it in my
front row.
notes.
Oh yeah,
On
there's
here.
one here.
Well, if you sit right here, Stormy, you'll reach.
Oh, okay.
Yeah, I just finished up on the last agile slide.
Ooh.
Now I have the plan of how you actually plan an agile method.
An agile method, a methodology.
I'm calling this a process, although agile is not a process, but there are processes that are agile.
Yes, agreed. Perfectly said. By the way, are you based here in Phoenix?
Yeah. Yeah. My earlier talk was on the solid principles,
Mm-hmm.
and we just had so much fun that she said, yeah, I'd love to have you do another talk. So I did the agile one. I actually did this agile talk a couple months ago here.
Oh,
So-
wow, awesome. Stormy, that's awesome. You get a 2 for 1.
She got a twofer.
All right.
Uncle Bob Martin.
Bob. No, not Bob. Bob Martin.
Yep.
There.
He's also, his real name is Robert C. Martin, but everybody calls him Uncle Bob. Uncle Bob Martin. Really, really good guy. He, along with a bunch of other people, Martin Fowler, Kent Beck, they all got together at this place called Snowbird in Utah. Was it Utah? I think it was Snowbird, Utah. And they all got together and they came up with these 4 principles. The 4,
Manifesto?
yeah, the Agile Manifesto, yeah. There's 12 principles and 4 values. There we go. I was trying to remember the word. So, okay, now that we've learned the 4 values of Agile, I'm not going to get into the 12 principles because that's a really long talk. But I am going to take those 4 principles and I'm going to put them into a plan. Okay? So this is a new plan of how you build your applications. First, you're going to have some sort of planner. Okay? A customer and a planner. And they're going to talk about things. Now, typically this would be like your Scrum Master or the project manager or something like that. But if at all possible, you want this to be more than just one person. You would like this to be a whole bunch of people that are a part of the team. But there is kind of one person that's kind of keeping track of some of these things so that you can kind of talk about things, like a secretary or something that's kind of tracking this communication. But from that discussion, whoever that is that's having this discussion with the customer, whoever it is, however many people it is, you end up getting a list of features from that customer. What does the customer want in my application? So let's say, for example, we come up with user management, document storage, customer management, inventory management, pricing, and vendor management. These are all features that they said that they want in the application. From this discussion, you're creating user stories about each one of these features. Who are the different types of people? Who are the different individuals that are going to be using these features? So let's say one of them is a manager. As a manager, I will be able to use the user management section to manage users, to add and remove and update users from the system. Okay, so that's what you're doing with your user stories. You are, as a particular type of person, as a manager, I will be able to do this with that particular feature. Okay, so these are your user stories. You have a list of features. You take those features and you put them into a backlog. Here we have some already pre-designed ideas, things that we already knew we needed to do from a previous discussion with the customer, or even things that they may not even necessarily known were necessary, like, like a database, if that was on here, but it's not. So we've got a splash screen, logo design, server setup, login, registration, authentication, and authorization. Now we're going to add those features that we just had the conversation about. We're going to add them to this thing called the backlog. So now we have a really long list of things that need to be done. Okay?
this side. So now the backlog contains all this stuff. All the stuff that was previously there, and now we've added the user management, document storage, customer management, inventory management, pricing, and vendor management. So we've got this big, long backlog. And what we're going to do is we're going to take a part of this backlog, and we're going to stick it into an iteration. But the first thing we need to do is define done. What does it mean to be done with all of these things? That's the first thing that we're going to do. Then we're going to add any previous bugs that we might have found. And now we start adding server setup, logo design, splash screen, authentication, registration, login. So we take these things and we put them into the iteration. Notice anything different between the backlog and an iteration?
It adds in a few things that the backlog hasn't thought of.
8, 7, 6, 5, 4, 3, 2, 1.
Yeah.
These are just dotted.
Yeah.
There's no particular order. This is an unordered list. This is an ordered list.
Okay.
Okay? This is in order of, what do you think?
Importance.
Priority. This is the first thing we should do for this iteration. This is the next thing we should do for this iteration. This is the next thing that we have to do. Server setup, logo design, splash screen, authentication, registration, login. These are the order of things of importance that we must get done. If this last thing doesn't get done, because we run out of time, hopefully that doesn't happen, but at least it's not the most important part of it, right, of what we needed to get done. So we have, this is unordered, this is ordered. Along with that, though, we need to keep our user stories, right? For each one of these features that we had up here, we have our set of user stories to go along with it, okay? And those eventually get broken down into a task list, because now we can actually start to say, what is it that we need to do to make these things happen? What are the actual tasks that I must accomplish in order to get these features done according to their user story? Okay, now you start to think, okay, I need to find a cloud host if that's where they're going to host it, install a framework, design 5 prototype logos because maybe they want us to do the logo design. Okay, home screen model, home screen controller, home screen view. This would be it for MVC application, for example. So I start to have my actual individual tasks that I must accomplish or my team must accomplish to get each one of these features done. And they go into this big, long task list. Okay? Don't forget the user stories. Okay? Always got to keep those with you so you know that what you're doing, each one of those tasks, is in some way fulfilling that requirement.
So it's on the tail of everything you do.
Exactly, exactly. Now I'm going to introduce you to something called a Kanban board. Okay? There's different variations of this, but it's basically the same principle. You take that task list of all those things that you broke down, all those individual different things that you must do, and you and your team are going to set up some different columns. Typically, I like another column in here between in progress and done, which is my testing phase, my QA. So typically, what you're going to do is you're going to take one of these, see, I put in QA testing, should be in there somewhere. Should be some sort of testing in order to go from in progress to done. But essentially, you're going to take those tasks, they're going to be assigned to somebody, whether it's yourself or someone else in the group. They're going to do these things, and while they're in progress, they're in the in progress. While they're working on it, that's where it resides. Then, after it passes testing, and you have fulfilled everything that requires it to be done, it is done. Okay? Simple enough. Very easy to follow along. And I've seen these where it's either a whiteboard or it's literally, this started out as a post-it notes. They write down. That's where Kanban actually started from. So, this new plan is actually a cycle.
Okay.
Okay? So, we collect our user stories and the features from our customer. We add the features to our backlog. We pick the features that we want to do for this particular iteration. We create our task list. That goes onto our Kanban board, and then we start to do our development. And we move things over to the done category, which then makes it done. Once it's done, which includes the releasing process, we go back to our customer, we collect more user stories and more features. And we start the whole process all over again.
And everything's completed in iterations.
Everything is completed in iterations. Right at this point. So what about those user stories? As a blank, I will be able to blank with this feature. Well, a user story is an acceptance test. And in fact, there's Cucumber, there's SpecFlow, there's actual testing frameworks that you can use that you write up your tests in a style like this, like how a user story works. So you can take this and it actually becomes your acceptance test. And once you can pass the acceptance test, it's done. So that's why user stories are so important. They help you define what is done.
Okay.
So to wrap it up, 4 core values: individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan, and the new plan involves collecting features from the backlog, or collecting features and putting it into the backlog, get user stories, select and order the most important features for the iteration, define what is done, gotta know what that is, create a task list based upon the features and the user stories, I should say, add the task list to the Kanban board, and track your progress until it's done. And then you do it all over again. Additional concepts you might want to look into: Pomodoro, basically 30-minute increments, 25 minutes of doing work, 5 minutes of just going.
He actually has a Pomodoro timer.
Yeah,
Idea?
I would love to meet with you.
I have it on my watch. Yeah. Velocity is basically knowing the increments of how much. It's basically a measurement of your unit of work. How much time does it take me to do something, and then you track that, and knowing how long it took you to do certain things will help you project how long it's going to take you to do future things. Because if it took me 6 units to get this done previously, I have a similar thing. It's going to take me probably 6 units to do that similar thing. Test-driven development, we talked a little bit about that. Behavior-driven development, feature-driven development, these are all really good development techniques. Solid principles, which was obviously the beginning of the course, big time. Clean coding practices, again, check out Uncle Bob Martin. Scrum, extreme programming, and lean software development. These are 3 other styles of Agile. And the one that I gave you is not really any particular one of those. It's similar to Scrum, but not exactly Scrum. I just gave you like my own personal way I like to do things, and it is Agile.
Added to that list, Sister Me, the one I'm trying to push on you is DevOps. It would fit on that list.
Okay.
And there's me again.
Steve, do you have a business card?
Yes, I do. I learned from the last time I did one of these and forgot to bring them.
Thank you, sir.
Yeah, no problem. Yeah, I'm a senior software architect for Gartman Technical. I do Agile coaching. I do, gosh, there's really not a lot I don't do. Actually, I was in tech support for a long time too. And
I need to grab a pen because I want to write down a little of your contact info.
oh, okay.
I'm sorry, I interrupted you.
No, you're fine. I don't mind at all. Do you have a pen?
I have a pen. I don't know if he wants to use it.
Uh-oh.
I would love to ask to borrow.
I have a very eccentric pen, let's just say that.
I wonder if I still have viewers.
You had 6 the last I looked.
Wow. 6 people have hung on for 2 hours.
Yeah,
Is it 2 hours?
something like that.
It's 4 o'clock. Wow.
I fell asleep
They've held on for
long
3
enough.
hours. I can't believe this has been 3 hours.
Can I see the previous page?
Additional concepts.
And it lights up when
Yeah.
you press down on it, so that's pretty cool. Gonna steal my pen.
Should I tell him the Mpemba effect story?
Yeah.
Oh dear.
But should I do the Impemba effect one or the Cotol company?
They're both pretty good stories.
Yeah, I like them both.
I think the Cotol.
The
Yeah.
Cotol?
Yeah.
Okay, all right. We'll pull that one up.
Here's the information again. Oops.
Oh, you want that?
Yeah, I was gonna break down some of this.
My website, programmingmadeeasy.com, that's actually just goes directly to my YouTube page. I've got about 300 instructional tutorial videos and various things. Mostly C#. Actually, what really got me popular, this is probably gonna surprise you. I don't know, maybe this will surprise you. The topic that I get the most requests to do videos about is Microsoft Access. Yeah.
Okay, didn't see that coming.
Yeah. I have found Access to be a very versatile application. You'd be surprised at what you can do with it you didn't think you could.
Yeah, I used to be an expert with Microsoft Access, and I agree that it's amazing what it can do. And
It's got limitations.
that one of the biggest ones being how many people can use it simultaneously before things start to go not so great.
There's ways of getting around that. You
Yep.
should know that. You don't have to use it as the relational database management system. You just use it as a front-end UI.
Yep, you can talk to T-SQL.
Yeah. Just like every other application needs to. It's got to have, if it's going to use a database, it's got to do that. Yeah.
Here, I'll be back. I'm going to use the restroom.
Okay.
That was 3 hours.
So, hand soap in the 1920s.
Okay.
This is a great talk. Everybody wants to know this thing. Hand soap in the 1920s. Back in the 1920s, hand soap was powdered. And it came in this powdered form, and you'd have to get like this container like this dispenser, okay? And you'd have this dispenser full of this powdered stuff, and you'd have to wash your hands you'd have to get them wet first, and then there's this little lever down here at the bottom that you push, and it dispenses a little bit, and then you wash your hands that way. So this was primarily the way that hand soap was delivered in the 1920s. But there was a newcomer on the market, which was the ivory bar soap, okay? And slowly but surely the market was starting to go to this ivory soap. And there were a lot of reasons for this. Obviously, it's much more efficient. Stores can just sell it right as a bar right off the shelf. If I'm going to use it, I don't have to keep cleaning these things out. It gets rusty inside this thing. I got to clean it out or take it off the wall and clean it up. And so it's just a hassle to deal with this. This is a piece of cake comparatively. So great idea. But there's a company called Cotol Products Company back in the 1920s. And it was run by this kid who's 21 years old named Cleo. And the Cotol Products Company, it did sell a bunch of different products, but none of them really successfully. And they were down to just this powdered soap, the powdered hand soap. That's all that they sold at this point.
Okay.
And it was obviously a diminishing market. So Cleo's really in a bad spot. And he decides to get his brother Noah involved, figure out some way to keep this company afloat. And they end up getting a meeting with Kroger in 1933.
Okay.
Okay, now Kroger, they saw an opportunity for something. They saw a market, but they didn't have a product for the market. They knew there was a problem, but they didn't have a solution. And so Kroger had this problem that was with coal stoves. In the 1920s and the 30s, coal stoves were the main way that you heated up your house and you cooked your food. Okay? It was more efficient than wood-burning stoves. But the problem with coal stoves is that they left this thick, dark residue, this ashy, sooty stuff all over the walls and all over the ceilings, everywhere. So Kroger asked Cleo and Noah, can you make a cleaner for walls? And Noah's like, well, we just make soap. But Cleo's like, yeah, we could do this, no problem. I'll put our butts on the line. I don't know how we're going to do it, but sure, we can make it. Well, Noah was actually the more enterprising of the two. He was a bit of the smarter of the two. He was the brains behind the operation at this point. And so Noah goes about trying to figure out some way of cleaning walls, get rid of this ashy, sooty substance. And so Noah tries a whole bunch of different things, and he eventually comes across this mixture of flour, water, salt, boric acid, and mineral oil. Just regular stuff that you can really find anywhere. It comes right off the general store, or go to any store and get this type of stuff. But he takes it and he puts it all together in a pan and he mixes it up, and after about 6 to 8 minutes, it turns into this clumpy, gooey substance that's really sticky, right? Mm-hmm. And this is perfect because all you have to do is take a clump of that stuff, stick it up against the wall, rub it all over, and then peel it off. That cleans your walls for you. It's a simple solution. Rather than having to take this soap and water and scrub brush and like this all the time trying to get that coal off and getting water all over the floor and stuff, you just take some of this pasty stuff and just go, rub it all over and then just peel it right off and just throw it away. Simple. And not only that, but it was biodegradable, non-toxic, all sorts of good stuff. So it's a perfect solution. Absolutely fantastic. And so they decided to go to market with this. They call it Cattol Wall Cleaner, the non-crumbly type. So, for wallpapered and flat painted walls. Now, things are going good for quite a while because this stuff is selling really, really well. They came out with the idea, they made it, it works great, and for a few decades, it's actually a really good hot seller. But there's a problem on the horizon, and that problem is oil and gas. Because oil furnaces are more efficient, and gas doesn't leave that residue. It's more efficient also at cooking your food. So you don't have this oily residue and stuff, or you don't get this coal residue. You get a little bit of oil residue, but it's not nearly as bad. It's easier to clean and it doesn't leave nearly the mess. So coal stoves are on the way out. And of course, with coal stoves on the way out, so is the coal smoke, and the reason for the Cattol Wall Cleaner. So, in 1949, there's Noah. Sales are slowing down, and worse yet, Cleo dies in a plane accident. So Noah's really not happy. I don't know, you'd see his frowny face. He's really not happy, crap. All right, so things are going bad for Noah and Cattol Wall Cleaner. So Noah decides to go and talk to his nephew, Joe. First thing he says is, damn, you're handsome, because that's a good looking picture of Joe. And he says, I bet you have all the girls you got to take out, all that money it costs you to go and take them out. Why don't you come work for me? So Joe's like, okay, all right, now we're happy. So Noah and Joe get this new partnership going on Cattol Wall Cleaner. And it just so happens that Joe has a sister-in-law named Kay. Now Kay, she works at a nursery. And Kay has all these kids running around, and she's got to figure out some activities for these kids to do. And she realizes that this wall cleaner, the kids love it. The kids absolutely love it. When they have it around the house, when she takes it to the nursery, the kids love to play because it's goopy, icky, sticky thing that they can just play with. So she goes and tells Joe about this discovery. And so Joe does something really, really cool with it. But that's not the reason why we're having this talk. The talk is actually on solid principles. Now don't worry, I have payoff at the end of the talk. I will tell you exactly what happens. Now, I could go into the solid principles, but I've already done it, so. But I'll give you the payoff here right now.
Okay.
Yeah. Play-Doh. Joe McVicker. Just add some food coloring and voila.
Mm-hmm.
Play-Doh. Completely remade the company and now that's what it's known as, Play-Doh.
Wow. Wow.
That's that story. You want to hear the Mpemba effect one? I don't really need the slides for this one. I'll put it up there anyway. Why not? So that's that one. I like that one. That's a good story. I discovered that not too long ago and came up with this.
Whole time I was like, okay, this is somehow going to parallel to software. I'm waiting for it. Well, let's finish that story and move on to solid principles.
Well, Sterling, since you went through solid, was the D for dry?
No.
No. Who says D on solid principles is for the dry principle? Wow.
See, what more I am. Huh?
Dependency Inversion Principle. Similar to, you've probably heard of Dependency Injection.
I use it.
It's not the same thing. Similar.
Well, I mean, dependency injection, I believe, depends on it, in a sense.
Yes, Dependency Injection is a form of Dependency Inversion.
So O is open closed.
Yep.
L is Liskov substitution.
Yes. S is single responsibility principle. O
Oh,
is
so I
open.
was right on that one.
Yeah.
Yep. O is open close principle. L is Liskov substitution principle. I is interface segregation principle, and D is dependency inversion principle.
Okay.
And then he showed me this thing where it was one version that wasn't solid, one version that was solid. The version that was solid looks like it would explode my brain, but I can see how it is much better to like any changes of the future. It's like more thinking now or more thinking later is the idea.
Mm-hmm. If you think about it now, you'll save yourself a lot of time down the road.
Yeah.
Yeah. I basically showed her how I could swap the entire application with just a few keystrokes.
Yeah.
This is my entire business logic and everything in this side. Now this is a brand new set of logic. All I have to do is just change this little thing, press go, and it's done. It's completely changed.
So this is similar to the changing the printer object thing that we were talking about earlier?
Yeah.
Perfect.
The car discussion.
The car discussion, you said?
Yeah, the in-car discussion I'm doing here.
Impemba effect. Have you heard of this before?
No.
The Impemba effect? So back in the 60s, there was a little Tunisian boy named Erasto. And Erasto was in school, and one of the activities that they did for their cooking class was they made ice cream. And of course, what 12-year-old Tunisian boy is not going to love ice cream? So Erasto is supposed to, the night before, go to the store and pick up some cream. But he forgets. And so on his way to class, he has to stop by the store and pick up some cream, but this makes him late for class. Now, in order to make ice cream back in this time, in the 1960s, what you did was you took a bowl, a big bowl of just, that you're gonna put your mixing stuff in, and you're gonna take the milk, you're gonna pour it in there, you're gonna take the sugar and whatever other ingredients, chocolate, vanilla, what have you, a little bit of salt. You stick that in there and you just stir it up really, really nice and good as it's boiling. Okay, so you gotta bring it up to boiling temperature and stir all this stuff in. Then after you've mixed it all together, you've gotta wait until it cools down to room temperature. Then you can take it and you can stick it in the freezer. Well, since Erasto was late, there was a problem. All the other kids in his classroom had already started theirs before he did. And so he was running late, they're all getting done, and there's only so much room in the freezer for them to stick their bowls of ice cream into the freezer. So as he's getting done mixing this up and the cream is still really, really hot and boiling temperature, all the other kids, theirs is starting to come down to room temperature. And so they're all starting to stick theirs in the freezer, and there's only so much room, so Erasto has to make a decision. Do I put mine in there now while I know there's still room, or do I wait and hope that there's room after I'm done? And of course, he's only 12 years old, so he decides I'm going to take this boiling hot bowl and stick it in the freezer before somebody else takes it. And it just so happens that he does this at the same time that the boy right across from him is doing this. So they both basically go up to the freezer and they both stick their bowls in. So this is a bit of a how can I say this? This is very, very not a very good thing that he's doing here, because back in the 60s, in particular in Tunisia, those ice boxes and those freezers were not very good. So sticking this boiling hot liquid in there amongst all these other things was giving the potential that not only could those other boys not cool as fast because his is warming up the inside of the icebox, but this could actually break the icebox. This could break the freezer because it doesn't have the capacity to do that. So Erasto's making a very risky decision in doing this. And about an hour and a half later, the teacher says, okay, everybody, go up and go get your ice cream. And he's crossing his fingers that nothing has gone wrong. So Erasto goes up and he grabs his bowl and he looks at it and he realizes that it is more frozen than the other boy who put his in at the same time. His bowl of ice cream is more frozen than the other boys who put his in at exactly the same time. And this fascinated Erasto. He had no idea what to make of this. So for several years, he actually conducts his own experiments. He takes and puts water in, he does all sorts of different liquids, juices, what have you. Sometimes he'd boil them up and then he'd stick them in the freezer and compare that to just regular room temperature. And every single time that he did this, the water, the one that was boiling hot would freeze faster than the stuff that was at room temperature. And so he ends up going to college eventually, and he goes and he talks to his professor, and his professor, in front of the class, he tells his professor, why does this happen? Why does this happen? And he asks this right in front of everyone, and everyone laughed at him, including the professor. Did not believe him at all, that sticking a boiling hot liquid was going to freeze faster than a normal temperature, room temperature liquid. So the professor laughs, but like, okay, I'm gonna humor this kid, whatever. So he goes and conducts his own experiments, and what do you suppose he found? Same thing. Every time that he put boiling hot liquids into the freezer, same time as room temperature, the boiling hot liquid would freeze faster. This rose to the Mpemba effect. Erasto Mpemba discovered the Mpemba effect, where water freezes faster if it is boiling as compared to room temperature. And there he is with his professor, Dennis Osborne, and they co-wrote and authored a paper which has been scientifically verified. It is a proven fact now that the Mpemba effect exists and that this actually happens. It's been peer-reviewed and everything. So this little 12, 13-year-old Tunisian boy became a world-renowned scientist because of this Mpemba effect. Now, the reason why the water freezes at boiling temperature is for a completely different talk that's not this one. This one's about agile thinking.
Okay. Well, that is interesting. But all I really want to know is, did he enjoy his ice cream?
Yeah, I think he probably did.
More frozen than everybody else's.
Mm-hmm.
You could be like, look, I got better ice cream than you.
Well, Miss Stormy, shall we
Should probably take off, huh?
we got dinner to put on? And
Yeah, I got dinner to put on. Yep.
She was a good student. It was too bad no more other people decided to join us.
Well, I feel kind of that this was fortunate for her to kind of get to monopolize you.
Yeah, oh, absolutely. Yeah, I'm glad that she did. I hope you learned a lot.
Mm-hmm. I've got plenty of resources here too.
That's good.
And I can sort of just compare and contrast as I go along, so this is great.
Yeah. Well, you've got my business card, so if you need anything, just let me know. And also, I've got the YouTube page, the programmingmadeeasy.com.
Mm-hmm.
You
And
can
I'm
find
sorry,
me on there too.
the place you work for again is called?
Gartman Technical Services. We're a small little father-son owned company here in town. I'm their senior software architect, so we've got a few other guys that are on the team with me.
I mean, is it product-based or professional services-based, or?
Both. Yeah.
Okay.
Yeah, we build software, but we primarily focus on custom building software.
Customer billing?
Yeah. We're gonna be putting together a product. I've been trying to work on a product for software as a service for a while, but we just keep getting more and more work our way, so I don't really always have time to work on that project, and it's going by the wayside, so we're thinking about hiring a couple of other people to help us get things ramped up again.
Is most of your clientele work based here in Phoenix, or is it out of state?
I'd say most of it is in town, but there's also, we have some customers that are definitely, I've got a couple of Fortune 500 companies that I do work for.
Right on.
Yeah. And then there was another one that I actually did IT service work for. I was their system admin for a while. So I've run the gambit of IT to software development. I've done it all from the highest level to, you know, just trying to figure out Microsoft Access as a programming language. Yeah. I did some really interesting, have you ever heard of Rubber Duck?
No.
I'm going to blow you away with this.
Mhm.
Unit testing and access.
Oh my goodness. Oh my goodness. Wow.
Real, actual unit testing in Microsoft Access. I bet you didn't think you could do that.
No, I've seen more than anything to help a client maybe who's trying to graduate from Microsoft Access, you know.
Yeah.
But actually unit testing it now. So, wow. There you
Yeah.
go. Now I know. Now there's another fact for me to.
The more you know.
I got demonstrations on my YouTube channel of how Rubber Duck works and stuff. So
Well, I might check that out, sir. But Steve, it's Steve.
Steve, yes. What's your name?
Brent.
Brent. Nice to meet you,
Steve.
Yeah, thank you very much for bringing her along so that I could actually have an audience besides my lovely wife over there. Poor wife just sitting there not knowing anything about what I'm talking about, but just trying to support me anyway.
I'm almost in the same boat.
Well, at least you're learning and you've decided to pick it up. That's really good. So
That's
2 months.
farther than I've got.
I feel like I've got 3 months of knowledge. There's a big interruption in the middle because of personal reasons, but yeah, I feel like that's what I got.
Okay. Yeah.
I figured, well, and actually this weekend I'm going to be giving to her an end-to-end example of a website just using ASP.NET and VC, but I'm also going to give her another end-to-end that involves a single-page application with React. Both of them are just going to kind of do the whole world thing. And actually I think we're going to switch from GitHub to Visual Studio Team Services because it has that fancy Kanban board that it's doing in.
It does.
So we can
Has full agile integration. You could even do Scrum.
So since already the assignments she had been working on, she was submitting them through GitHub and doing pull requests, I could review her code.
Mm-hmm.
But now I want to take it to another level where I'm actually putting assignments in as cards, you know.
Well, I gave her an assignment today.
Oh.
Let's see if she remembers what it was, though. I doubt she probably does. We kind of glossed over it since it was a bit higher.
High level.
Yeah, high level thinking.
Take the input of the make and year of a car.
Mm-hmm.
I forgot what the rules were, but
yeah. So basically, it was. Maybe I'll open the other one. There were only 4 rules that I listed here. So some of these things you could cheat a little bit on. Yes.
yeah, there it is. As soon as you put that up, I was like, oh, I'm gonna die.
Yeah, users can enter either a 2 or 4-digit year. The make does not need to be case sensitive. We are only accepting Mazdas 1997 and newer, and we are only accepting Toyotas between 2006 and 1999. So any other makes or any other years, we're not accepting. Very simple. And then this is where I've got 2 versions of the same application. One where it's the pretty straightforward way that you would typically find somebody who's just kind of trying to figure things out, where it's just basically a bunch of ifs and elses and stuff like that. And then I've got another version that basically has no ifs, no select cases, no new instantiations of any objects, no direct, everything is abstracted. Everything is abstracted. Everything is abstracted.
Yeah, I saw that, and I was like, wait, what? But how does it know?
Yeah, dependency injection and dependency inversion. Yeah, it's
Actually,
mad.
that's what people feel about dependency injection. Like these dependencies just started falling out of the sky, is what people will say. Where does it come from? And they're all of a sudden here. Well, that's awesome. I'm going to be looking at that myself, so I can look at it with her and discuss it with her.
Yeah, that'd be great. I've got. You're familiar with C#?
Yeah, I am a software engineer. I'm a freelance developer, architect. So.
Okay,
He's
so
the king.
maybe you could help her out with the lambda expressions I've thrown in there then. I've got some func of t's in there, so
Yeah.
with some lambdas. So that would be a really big treat for her if she could figure that out.
Yeah, I saw a lot of alien speak.
It does look like alien speak. Thanks for coming, guys.
All right. Thank you, Steve. Nice meeting you.
Nice to meet you too.
Thank you for putting the extra time in.
Oh, you're welcome. I'm
And
happy
thank
to.
you for letting me, I'm Brent.
I'm Joy.
Joy, nice to meet you, Joy. All right. Joy, Steve, take care.
Thank you.
You figure stuff, you get your,
Yep.
your reader, self out here? How'd it go? Very well.
Steve's awesome.
Oh, yeah.
You guys